nanomaterial for green energy application. What is green energy application and why it is called as a green energy application? That we are going to see. There are some application which comes under the green energy sources. One of the application is photocatalysis and another is water splitting. So these are the two applications I am going to teach you the various aspects of the photocatalysis and water splitting. Yesterday we have seen how to synthesize the nanoparticle. So if you recall your memory, you might know about the technique that are used for synthesizing nanomaterial. One technique which comes under top-down methods, and we have seen there are 4 techniques, but beside 4 techniques there are 10 techniques that can also called as top-down method. Due to time restriction, I just explain you the 4 techniques. So here you remember that the bulk material is bigger, and then you start from the big and end up with the small particle. In case of bottom-up, you started from the clusters, atoms, and then you ends into the nanoparticle. So these are some of the material that you can synthesize, you can prepare using the 2 approaches, top-down or bottom-up technique. So you can prepare various thin film, rods, wire, quantum dots, or nanocrystals. In case of maybe biology, they can also prepare the proteins. This is the scale through which you can come to know that if you are interested in nano and micro, most of the top-down technique are prefer to synthesize those structures. And this is the last slide for yesterday's review. What we learned yesterday, we learned about ball milling, thermal evaporation, laser ablation, and sputtering. Then chemical vapor deposition, hydrothermal method, and co-precipitation method, and last was sol gel. So these are widely used technique to synthesize the nanostructures. Now coming to today's talk about green energy, application in green energy. Today's lecture will cover 4 topics. First, what is photocatalysis? Because most of you might not well aware about the photocatalysis. Few students are doing the research in the field of photocatalysis. They might know various aspects, but most of the students, when I interact with you, I found that you are not working on the photocatalysis. So this topic will be interesting for you to know the various aspects of photocatalysis. What is photocatalysis really means? Then what kind of recent development occur in the field of photocatalysis? Then there are some examples to prepare the nanocomposite material based on metal oxide and see how they behave when they are considered for the photocatalysis application. So I will show you some of the example how these nanocomposite material, ternary nanocomposite material, binary nanocomposite material give better performance for photocatalysis. And fourth is the water splitting for hydrogen production. The title is Green Energy. Green energy means it should be environment friendly, sustainable. It can be used again and again. It cannot create carbon dioxide or byproduct which is harmful to the environment as well as humankind. If we find such kind of energy sources, those sources are nothing but green energy sources. You might heard about renewable source like CNG you use for the fuel, but CNG also create CO2. So it is renewable energy, but still it has a problem of CO2. It's better than the petrol gasoline, but still it has some disadvantages. So when we look for the complete green sources, it means that it should not create any byproduct that can harmful, that can create pollution, that can cause some problem to human. So those sources are good sources for green energy application. So here, earlier we were using non-fossil, that was having bigger problem of creating CO2 and various byproduct. Then we started to use renewable energies. So renewable energy means it can be sun or some kind of gases. But when we use renewable energy, it is not complete green energy. It needs some kind of assistance of electricity or some other method support, that we cannot say it is a green energy. We can say it as a renewable energy. So in the search of green energy, the thought to find out such energy sources with the help of the sun. Sun is giving energy, and that energy can be utilized for various purposes. For example, photocatalysis, we have lots of sunlight, and those sunlight can be used for the application such as photocatalysis and hydrogen production. Then when we search for green energy application, we have to be very careful about the material. What kind of material we should choose? Those material should be easily available. It should be low cost. It should not be harmful. When you are handling those sources, it should not create any cause or problem. So those factors we should consider while choosing the material for green energy application. And then if we select a particular material, that material might be prominent candidate for green sources. So earlier, non-renewable sources, then we started to use renewable. Now we are focusing on direct green energy sources. So there is no harmful to the humankind or environment. Such sources are good for our society. Now in the search of such kind of material or energy sources, one of the application is photocatalysis. Before explaining you the meaning of photocatalysis, I want to tell you why photocatalysis is important. First of all, our earth has 70% of water. But 70% water, most of the water is covered by the sea. Now, when we talk about the water that comes from sea, has various mineral. We cannot use that water for drinking or for cleaning purpose, because various kind of minerals, salts can be found in those seawater. To process seawater, it's very expensive. So when we want to drink the water, we usually drink the water which comes from the river. When we are using the water for the factories, companies, those water also comes from the regular sources such as river. We might use the cleaning water again and again. There are several processes. But this seawater is not useful for us, not for drinking, not for any kind of cleaning purpose. So remaining 2.5% is water that can use for drinking and cleaning purpose. As you know, our population is increasing. Now we are getting enough water, present generation. But in future, if population increase, there will be shortage of water. So how to deal with this situation for the next generation? We have to find out solution for next generation or even for us. You might not know what will happen after 10 years. We should not sit, something will happen and we'll see. We have to find out some kind of solution for our next generation. So we should be careful while using this 2.5% of water. The number of people, the population increases, water will not increase. Water will not increase. So the problem for reusing the water will always come. There are many factories, companies, units that use the water for cleaning. And when they use the water for cleaning, that water consists of some kind of organic pollutant. Organic pollutant means it has some kind of organic material which consists of carbon or hydrogen based material. Now, when the water which was clean water but used for cleaning purpose, it get contaminated. Contaminated means now there are some organic pollutant put or come into the water and it become contaminated. In our regular language, you can say it is a dirty water, unclear water. Now jobs come how to clean this water and reuse it. Remember, we are not talking about the drinking water. We are talking about the water which comes from the cleaning in the factory such as textile industry, pharmaceutical industry. They use lots of water and that water can be contaminated. It consists of various kind of organic species that we call as organic pollutant. So how to clean this water and make this water for reuse? If we successfully clean the contaminated water into the pure water or clean water and we can able to use that water again and again, that process require photocatalysis. Means it is one of the methods to clean the contaminated, impure, dirty water into clean water so that we can use it again and again. This is the importance of photocatalysis. When we will talk about the photocatalysis, during this talk, you might hear various terms. What is photocatalysis? What is catalyst? What is photolysis? What is radical? What is organic pollutant? What is photon? What is energy? These terms I will frequently use for the lectures. So those whose background may be mechanical, electrical, or they are not belong to physics, chemistry, they might heard this term for the first time. Don't worry, I am going to explain you some of the basic terms so that today you will understand what photocatalysis really means. So photocatalysis, catalyst, photolysis together is photocatalysis, radical organic pollutant. I told you about the organic pollutant, energy, green energy, photon means light. So all kind of words will be comes while I talk about the photocatalysis. Terms photocatalysis comes from photolysis. What is photo? Photo means photon. Photo means photon. So we took this photo here. That photo means photon, means light energy, some kind of light, artificial light or natural light. So that photon, we just took the photo, and lysis means break down. You break down something, electrolysis. So where electricity is used to break down the material. Photolysis, you use photon, light, to break down the material. So this is the basic term, okay? Photolysis. Now you understand what is photolysis. Photolysis is the process that uses light energy to break down materials, okay? And when you break down the material, I told you contaminated water, it consists of organic pollutant. So if you want to break down those material, such kind of process is required. When we are dealing or doing the photolysis, it can be done in the presence of visible or UV light. Photon, light, okay? So we need some kind of light to do the photolysis. If you want to do electrolysis, you need some kind of electricity. Photolysis can be enhanced. Simply, when you put the light, photolysis starts. But if you want to enhance the performance, efficiency, you can add something, ozone or H2O2, hydrogen peroxide. So that process become faster and performance increase. Why? Because we want solution in quick time, we want solution in better way, it should be faster than earlier solutions. So that's why we add something so that this process can give a good result in a short time. Then this photolysis, in the photolysis we are just using visible UV light, and sometimes we add some kind of ozone or hydrogen peroxide. Photocatalysis is the improved version of photolysis. Photolysis, light, breakdown material. And now you are adding cata. What this cata means? Cata means catalyst. So photocatalysis, light energy with the help of catalyst. It's additive. Earlier we are not using additive in photolysis. Now we are using some kind of addition of material that is known as catalyst to improve the breakdown. Because yesterday I have shown you that CVD methods. So there was methane, C and H, methane and hydrogen, CH4. So carbon and hydrogen break down there, decompose, separate. Similarly, when you want to clean the water, organic pollutant has a certain species that is made up of carbon and hydrogen. So you want to break down that chain and clean the water. So when you want to break down, there is a chemical reaction. And if you want to enhance this process of breaking down the material, you need catalyst that assist. Like if you are running, somebody push you, you will run more faster. Because you have your own energy when you are walking or running. And if somebody push you, your running speed will be faster. Because you take the help of someone or somebody help you. In the same way, if we use the catalyst, this photolysis process enhance. So catalyst is a substance that increase the rate of reaction without being consumed. this term is very important. Without being consumed, okay? It break down the material. Like if I want to go until that door, somebody will push me until the door and he will come back again here. If next person come, he will again push. So without being consumed, okay, nothing will happen to him, that substance. So substance that called as catalyst help to increase the rate of reaction without being consumed. This photocatalysis is inspired by the nature or natural process we call synthesis, photosynthesis, photo, light, synthesis, making something. So in this photosynthesis, there is a light from sun. It comes on the leaves of tree, and then it can create O2. It can create O2. And this formation of oxygen in biology we call as photosynthesis. There is a chlorophyll which assists this photosynthesis process. Similar kind of concept is used in the photocatalysis, because in photocatalysis we are using photocatalyst. In photosynthesis there is a chlorophyll which help to create the oxygen. So photocatalysis can be done in the presence of light and water. Why light? We need photon, okay? That is one thing. Why water? Because we are dealing with the water. We want to clean the water. So photocatalyst can create strong oxidation agent and electronic hole to break down the organic matter to carbon dioxide and water. When photosynthesis occur, creation of oxygen, okay? When photocatalysis occurs with the help of light, what happens? You can create certain radical, okay, OH radical or electron. And that OH radical can react with organic pollutant, and then it can create H2O in the clean form and CO2. This is the basic principle of photocatalysis. I will explain you in more detail what photocatalysis, how photocatalysis occurs. And this photocatalysis is totally based on the photosynthesis. Here the chlorophyll can act as a catalyst, There is an oxidation and reduction process occurs. There are electrons, there are hole. When you put the light on the any kind of material, on the photocatalyst, the electron excite, the charged particle excite, and they can make movement from valence band to conduction band. While they move from valence band to conduction band, electron usually move from valence band to conduction band. It creates the reduction and oxidation of a charges. So with the help of UV light we create in laboratory, but natural sun can provide UV light directly. When we do the photocatalysis in laboratory, we cannot use sunlight directly. We use UV light of the same wavelength, or we can use LED light also. So when we use UV light, electron can jump from valence band to conduction band, and reduction process can occur. On other side, this hole can participate in oxidation. So movement of electron. Why electron is moving? Because there is a light. You need certain kind of energy. I told you I want to go to the door, but myself, if I want to go, I am going very slowly. However, I want to go faster. So some kind of energy is required. Mechanical, kinetic, something, someone should push me, then I can move forward. Otherwise, I will sit here. So electron is sitting here. Once you give energy, it will go. So while going up, it can have a reduction of charges and oxidation also. So this oxidation and reduction process occurs simultaneously, because once electron move, hole created, hole participate. So this is continuous process, continuous process. Light is coming on the semiconductor or photocatalysis. So with the help of light, oxidation and reduction process occur. And oxidation reduction process occurs means charge movement of charge particle. So charge particle should move fast to give the faster, better result and efficiency. So the efficiency of photocatalysis depend on how one can prevent this charge recombination. Charge recombination means this electron and hole, how they move faster. Now, you take one photocatalyst, okay? Any material, semiconductor material, two-dimensional based material. This is your photocatalyst material. Light pass, or we put the light on this surface of photocatalyst. Okay, this is the surface of. On the surface there are positive, negative charge. When we put the light, charge get excited. Both charge get excited. Then there is a oxygen. So oxygen react with this negative charge and it create O2 minus. Okay? Earlier we put the light on the photocatalyst, positive, negative charge get excited, electron can react with the oxygen, it can create O2 minus. Then remaining hole, this is very important. Remaining hole, we have water also. So remaining hole can react with H2, and create OH radical. This OH radical name as hydroxy radical. So this hydroxy radical are the real component that decide the performance of photocatalyst. Once this hydroxy radical are created, there are bacteria or organic pollutant in the water. Now this OH radical are ready to react with this organic pollutant, organic molecule or bacteria. Then they react, okay? They react with this OH radical. Once OH radical and this organic pollutant react with each other, H2O and CO2 is created. So this way, finally the water become clean, and of course there is CO2. But the good thing about this technique, you don't need any electricity. You just need solar light. You have not used any kind of electricity. You don't need any kind of money. What you need only photocatalyst. That's it. Solar light is already available. So this way we can create H2O and CO2. This is only one light, one photon come and this thing happen. It happen in few seconds, nano femtosecond. And this is continuous process. That's why photocatalyst material can be intact during the photocatalysis process. So this is a continuous reaction. Charge go up, charge excited, electron go up, then positive charge react with oxygen, electron react with oxygen, and positive charge react with the water. They create hydroxy radical, and hydroxy radical can react with bacteria or organic pollutant, and this way you can create the H2O, that is water, and CO2. The main thing in the photocatalysis is creation of radical, break down the material. Photocatalysis means break down the material. So organic pollutant react with this radical. If radical is created, your job is almost half done. Next part, this radical will react with organic pollutant, or this radical will kill organic pollutant, and you can get the clean water. So earlier, when we put some kind of organic pollutant in the water, the color is blue. It is methylene blue. Okay. So after certain time, you put the light and you check after 10 minutes, after 20 minutes, 30 minutes, 40 minutes, or 60 minutes, the color of the solution gets changed. So this shows the formation of clean water with the help of these photocatalysis, which create this hydroxy radical. So this is the basic thing, what happened during the photocatalysis. In short, I will explain you again. Photocatalysis, when you put the light on the photocatalyst, charge get excited. Okay, positive, negative. Negative electron charge react with the oxygen, positive react with the H2O, then it create OH radical. OH radical can react with the organic pollutant, and once they react, H2O and CO2 can be formed. I hope that you can understand this process of photocatalysis now. Why this photocatalysis is important, or what kind of advantage, benefit this photocatalysis method have? First is economic. What it need? Yes. Sorry, this one? No, it's clean water. Because, yeah, bacteria means, you say corona or organic pollutant. Organic pollutant, they are mostly made up from carbon, hydrogen, okay? So, they have a strong bond, okay? If you break that bond, then they will separate. And once you separate, water will be clean. If they are not separate, okay? If they are not separate, water will remain as it is. Visually, you can see this in the photocatalysis. Like you put the light, you put such kind of bottle for 10 minutes, okay? Your solution color will be little bit lighter. Again, 10, 20 lighter. After 1 hour, 45 minutes, depending on what kind of photocatalyst you use, the time is also changed. First is economic, means it is a low cost methods. That's why it is preferred to use for the photocatalysis purpose. Efficient. Efficient means it gives quick result. Visually you can see it. Green technology, because as I told, no external source, no external support is required except photocatalytic material. So this is the 3 biggest advantages of photocatalysis process. I told you that we will use only light, okay? But it not only light, it consists of water also. It consists of organic pollutant in the liquid medium. So what factor, what are the parameters that affect this photocatalysis process? For example, this light. So it depends. when you increase the intensity, the process of photocatalysis might spoil. So semiconductor concentration means how much photocatalyst you are putting into the water. For example, if you took 3 milliliter, 4 milliliter of water, contaminated water, if you put 1 milliliter methyl orange, that is organic pollutant. Now, how much percent photocatalyst you will put? 5%, 10%, 20%. If you put more concentration, result will be fast. But more concentration is not good. It should be less, so that less material can give better performance for bigger water quantity. So concentration of semiconductor material, or let's say photocatalytic material, is important. We have to choose certain percentage. It may be 3%, 5%, or even 10%, but not 50%. That will be too big. Light intensity. Now, intensity of light. How much intensity? What kind of light source you are using? How much energy you are giving? Whether you are giving 100 milliwatt, 200, 500, 7 or 1 watt. That intensity can affect the result. Temperature. We are dealing with the water, so temperature is important. And pH also. pH can also decide the photocatalytic performance. So while doing this process, we need to consider these 4 parameters while deciding the performance of photocatalyst. Where are the application of this photocatalysis material? The application of photocatalysis material is in dye or textile industry, where unclean, contaminated water, which consists of various organic pollutant, is thrown out after using the water, or pharmaceutical waste water, or recalcitrant compound, means the compound which cannot break easily, hard compound. So even though the hard compound means, like I told you about the diamond and graphite. Graphite you can break it easily because bond is very loose. You need a small energy, you can break the pencil. Graphite is made up of carbon, but you cannot break diamond. You cannot break the diamond. Diamond bond is so strong, you cannot break it. That's why we call diamond as a hard material. Similarly, some organic molecules are very hard to break. Those organic pollutant can be break easily with the help of photocatalysis. Now I will move to the recent development. What kind of nanomaterial use for the photocatalysis? There are various research papers on the photocatalysis. This research on photocatalysis initially was started in 2000, around 2003. There were less than 1,000 papers. But now, in 2021 and 2024, this number might reach to more than 10,000. So you can see it was less than 1,000, even few hundred, and now it reached to more than 10,000. So number of researchers who are working on this topic is increasing. This term photocatalysis is derived or comes from the experiment done by Professor Fujishima of Tokyo University in 1967. He was working on TiO2, titanium oxide, and he wanted to split the water. He want to split the water. As I told you that earlier electrolysis was there. Electrolysis, electricity and lysis breakdown. Electrochemical, electrolysis, it need some kind of electricity. So he want to do the photocatalysis, and he found that it is possible to do the photocatalysis with the help of light, without using electricity. This is very important, without using electricity. And 1967, that is almost 60 years before, he was doing this research. The first major paper come in 1972 in the Nature. And in 1980s, researchers started to think to use titanium oxide for various purposes, for solar cell, for photocatalysis, but very few researchers was working. In 1992, technology to apply thin layer of TiO2 was developed in Japan. So it started in 1960, and you can see after 25th year, first commercial breakthrough come for photocatalysis. And in 1990, some of the companies started to make self-cleaning window. Now, what is self-cleaning window? So if you put the certain kind of coating, the moisture cannot stand on the windows. So those windows called as self-cleaning windows. In the winter, the temperature outside is cold, but inside is hot. When this difference in the temperature is there, sometimes you can find the water particle stay on the glass. So if you are using smart window, that water particle will not stay. So those kind of glass is called as smart windows. Smart windows. So this is the first kind of application, comes in 1990s. And after that, people started to work on photocatalysis by doping the metal or non-metal and visible light driven semiconductor. Semiconductor means some kind of oxide material, TiO2, SiO2, WO3, and doping metal, Ag, Au, or some non-metal, zinc, and so on. Heterojunction semiconductor. Initially, they work individually, metal or semiconductor. Later on, heterojunction, binary, like you can use metal and combine metal with some semiconductor. For example, TiO2, Au, Ag, SiO2. So make binary composite material, heterojunction material, or even oxide-oxide. So those kind of heterostructure can be studied for photocatalysis. And then SPR enhanced photocatalysis. You can make or add the metal particle which can have surface plasma resonance. For example, Au. If you want to enhance the performance, like we started with photolysis and we add catalyst, performance increase. But still, if you want to increase the performance of photocatalyst itself, what are the parameters that can really help to enhance the efficiency of photocatalysis? First of all, what kind of nanostructure you are preparing? Whether they are particle, they are rod, they are metal, they are sheets, what kind of particles, nanostructure you are preparing, and whether it is useful for the photocatalysis. That is one of the factors. Extension or absorption in the visible region. So we are using visible light, okay, sunlight. So that the nanostructure should be very sensitive to visible range. So it can extend that visible band. If nanostructure cannot give the response, then we will not see the photocatalysis, enhanced photocatalysis. So while choosing the material, make sure that that material should be very sensitive in the absorption region within that visible range. And titanium oxide was researched from 1967 to till date. But last 12 to 15 years, especially after the graphene discovery and Nobel Prize, researchers started to work on two-dimensional structure. And that two-dimensional structure is non-titanium base, because titanium oxide has some disadvantages. So there are three factors. What kind of nanostructure you are preparing, whether they are sensitive to the visible range. Third, that must be non-titanium based material, because titanium has some kind of disadvantage. The efficiency is limited if you use titanium oxide. That's why replacement for the titanium is going on. Like solar cell. Till today we are using silicon, but people are started to find alternative to silicon, low cost material. So this is the progress made in the field of photocatalysis so far. Metal, these are the noble metal, Ag, Au, platinum, palladium, and these are metal ion, zinc, aluminum, copper, and so on. And other oxide like zinc oxide, TiO2, SnO2, these are various combination of N-type and P-type metal oxide that can combine with this metal or metal ion. So there were many papers which consist of, for example, CO2 Sn or Fe2O3 Au Ag, and there are several combinations. They try for photocatalysis, but still today the efficiency is not good. That's why research is still underway. And since this combination of metal oxide or metal oxide semiconductor with simply metal not good, then they shipped this metal oxide with some kind of carbon based material. For example, CNT, reduced graphene oxide, or multi-wall carbon nanotube. Metal oxide, carbon based material. Metal oxide, metal. So binary composite, you will find several papers. Last 3-4 years, instead of this binary, the ternary composite can be prepared for photocatalysis. Why? Because metal oxide, especially TiO2 like metal, has some difficulty in the rapid electron hole recombination. So that electron hole recombination is the disadvantages, and insufficient light absorption range. Okay? Up to certain it can give the response, but it cannot extend its absorption band. So that's why, due to the less rapid electron hole recombination rate and insufficient light absorption range, some metal oxide is not enough for photocatalysis. To overcome this problem, as I explained in the last slide, metal can be added to faster this electron hole recombination, or certain kind of doping with rare metal or iron metal can be added, and then you can deposit, you can create the nanostructure which is consist of P-N type of semiconductor. So what basically you did to overcome with this problem, you add metal, but still the efficiency is not up to the mark. We still want to improve. So another thought come, we can couple this semiconductor metal composite with carbon nanomaterial. Earlier, metal oxide, then there is metal oxide and metal, or metal oxide and carbon, and now it's metal, semiconductor, and third is carbon nanomaterial. Carbon nanomaterial or two-dimensional material. So the idea of using the ternary composite may overcome with these disadvantages. So in this way, we can enhance this light absorption ability and separation of charge, or we can increase the electron-hole recombination rate. So in our laboratory, we have also worked on certain kind of ternary composite. Yesterday, I have shown you one of the slides about the synthesis of making indium selenide nanocube. We are basically working on two-dimensional materials in our laboratory. So two-dimensional materials are very interesting material because of its property. Two-dimensional, day before yesterday, we have seen the type of nanomaterial, okay? So if you remember, two-dimensional material is a sheet-like material. So those material has large surface area and higher electron mobility and optical transparency. So these are the parameters which we consider should be important when we took them for the photocatalysis. Then oxide material, although TiO2 has this one, but other oxide material can be tried with this two-dimensional material like Fe2O3, SnO2, WO3. And those material should be having low cost, small size. That is the crucial. And in addition to two-dimensional material and metal oxide, this metal is also added and make two-dimensional semiconductor and metal composite. So metal enhance photocatalysis. The role of metal is the same. As I told you, I want to move to the door, somebody should push me. So this metal nanoparticle push these charges quickly and enhance the recombination rate. Each component has certain role. So individual role, if you mix them together, make ternary composite, then end result is good. So to make the nanocomposite with the help of two-dimensional or based on the two-dimensional material, we can create the composite material of two-dimensional carbon nanomaterials and metal. Together, we can make two-dimensional nanocomposite with different surface morphology. It may be nanocube, spherical, nanorods, or simply various kind of hexagonal shape. And then tested for photocatalysis. We are using laser ablation, and we have created this kind of structure in our laboratory. So this is nanocube, this is nanoparticle, quantum dot, these are nanorod, nanorope, like this is octahedral structure. So all these structures is created in our laboratory. So those are structures, like this is tin oxide structure. These are like bismuth sulfide. These are indium selenide two-dimensional materials. And we have also created Ag nanocube. Similar to indium selenide, we have also created Ag nanocube. So various surface morphology can be possible to create by using the laser ablation. To create this material, you just need 20 minutes or 1 hour. Within 20 minutes or 1 hour, this process can be created. Even laser ablation is also eco-friendly technique, similar to photocatalysis. You just put something into the water and you get the nanoparticle within few minutes. So this is the one of the nanoparticle we have created using the laser ablation. I am not going to tell detail. I just want to show you the surface morphology. Our aim is to create the ternary composite. So ternary composite can be created using the hydrothermal process. Initially, we create two-dimensional material using laser ablation. And then metal like AgAU also created by laser ablation. Then we put oxide material in this hydrothermal autoclave, and after hydrothermal we can perform photocatalysis. Now first example is this. This slide I have shown you yesterday and you already know about this, so I am not going to explain this slide again, but you can just understand that we started with the bulk material which has the size of 2 micrometer. Okay, this is 1 micrometer, okay, and this is sheet like structure. Okay, sheet like one paper on another. There are number of sheets, 1, 2, 3, 4. So this sheet like structure is converted when we change the time from 5 minutes to 20 minutes, and we can get the nanocube. This is the same slide which I have shown you yesterday to show you the difference before and after laser ablation, transformation of thin sheet into the nanocube. This is the same thing. And indium selenide, which was created by laser ablation, was mixed with the zinc oxide and AU. Here AU was also created separately by laser ablation, zinc oxide by sol gel method. So individual nanostructure was created by different technique. They mix together and put into the hydrothermal autoclave, and after hydrothermal we can create the ternary composite. This way, hydrothermal, you can create the ternary composite and put for the photocatalysis like this. You put xenon lamp. For this research we have used the xenon lamp, and this is the sample. I have shown you the one of the slide where we are using methylene blue. The solution color is blue. After a certain time it becomes white. So this is the images of ternary composite. Now look at the performance. Here this is first, that is A is indium selenide nanocube. B figure is indium selenide AU, okay, and C figure is ternary composite. So performance wise, if you look at individual nanocube cannot show better performance, then we add AU, little improve, but after making ternary composite, look at the efficiency. Within a certain time, it can show better photocatalysis performance. So this shows that if we make the combination of semiconductor oxide material, two-dimensional material, and metal oxide, metal particle, metal nanoparticle. So combination of metal nanoparticle, oxide material, two-dimensional material can give better performance. What is the role of Ag here? So Ag can transform the electron to the zinc oxide, and then zinc oxide to indium selenide, and then indium selenide can help to create the photocatalysis process. So this process of transportation happen quickly with the help of this metal. If there is no, then this process will slow down. But with the help of this metal oxide, the process can occur quickly and you can see the result. So this suggests that both metal nanoparticle and oxide are equally important when we make the ternary composite based on two-dimensional material. Another combination, it was binary, not ternary, but I just want to show this is the interesting result. We started with WS2. We started with WS2 and we create WO3 minus X. In the laser ablation itself, solar energy used, we are using the light laser energy. So laser energy break this W and S2 and O come from water and it can create WO3. That's why this result is interesting. Another also, SNO. We took SNO and water is the solvent. Then SNO is transformed into SNO2. So both make separately, then we just add them, do the probe sonication for photocatalysis. These are the result. Initially, you can see petal-like morphology, and these are octahedron SNO2, and on octahedron SNO2, WO3 can be seen. This is the characterization. I will not go into the detail because of time, but it confirms the formation of these binary structures. Binary structure can give better performance, although it is not 98-95%, but if we add some metal in it, so this efficiency will definitely increase. However, it gives an idea that we can use SNO2, we can use WO3 while making the ternary composite. So after this, we are trying various combination with the WO3 material. Sometimes our result is not good, but it gives a direction that certain material are useful. They can highly responsive to the UV light. Then such kind of combination is good. We can add either metal nanoparticle or other two-dimensional material and make a ternary composite, and that ternary composite might be shows a better photocatalytic behavior. Now the last part for today's talk is water splitting for hydrogen production. First slide, I have explained you that why we need photocatalysis. Now, why we need hydrogen production? What is the requirement? Why we want to do the research in the field of hydrogen production? Everyone is looking for clean solution, okay? Green energy. So, clean energy source. Everyone is looking for, there is a demand for green energy. That's why this is one of the maybe methods that can be used to create green energy. Now, energy security. We have limited energy sources, fossil sources. So we must, fossil sources mean even your petrol, gasoline are limited. After certain year, it will. Of course, we are using electrical vehicle, okay? But still, it need electricity. And if you need electricity, again, CO2 is created. So it is harmful to the environment. So we are looking for green energy sources. So direction or finger goes towards the water splitting. Economic growth. Like our economy increases, the price of this fuel is increases, the storage of this regular non-conventional energy sources will definitely decrease with the time, but their price will increase. So to overcome with this problem, we should find out alternate sources. And this is efficient. It can show the efficiency about 75%. Portable, like when you want to use the or you want to create the hydrogen, it can create with a portable instrument that you can easily carry. So it needs less space. That's why such kind of maybe methods that create hydrogen production is useful, and one can consider water splitting for the hydrogen production towards the source of green energy. Now, when we think about hydrogen production, what are the measures we must consider when we are searching for the hydrogen production? We have to build the infrastructure, because at present there is no infrastructure. And safety concern is also a problem that we are dealing with. We are not sure how much energy sources we have at this moment and when it will finish. It may finish in next 20 years or 30. I'm talking about the fossil energy sources, the non-conventional, non-renewable sources. So the security will be the concern for this kind of production. We have to look for the hydrogen production, because security is related with the energy. If you have energy, you can do many things. So in future, energy will be one of the crises that humankind is going to face. And today we say that we are using renewable sources like wind energy, solar energy. You can see many everywhere. But in reality, the contribution of these renewable sources are not much. If you go to the power station, like how this electricity is generated, those electricity is coming from, non-conventional sources where CO2 is created. So the contribution of these renewable energy sources is less, very less. Most of the, power is coming from the fossil sources or natural gas. And those can create CO2 also. So the solution for this kind of problem that we are facing or we will face in the future is going toward the water splitting. And water splitting application can be used in various fields like industry, transportation, building, and powers, or we can store this hydrogen for long time. So you can store and use later on also. That's why this hydrogen production is important. And once we succeed in this hydrogen production, then it can be used in various industries or various applications. Now, we want to create hydrogen production. Why water? Why only water? Because water is widely available. Of course, water is made up of H2O, hydrogen, oxygen. Since water consists of hydrogen, oxygen, and we are looking for hydrogen, we will choose hydrogen. We are not interested in oxygen. Okay, so water is chosen because water consists of hydrogen, and our target is to create the hydrogen. So water splitting is the process in which water is splitted into hydrogen and oxygen. Split. Same process. Like I told you, organic pollutant, break. Break is another word is split. Decompose. Almost similar word. They separated. So 70% of water is made up. Now, here, 70% for what? Including seawater. Hydrogen production can be gain much more interest as oil, like gas. And it is other non-renewable fuel become increasingly depleted, and expensive. Non-renewable because gasoline and other sources will be expensive in future. So hydrogen is the source of energy that might be relatively cheap as compared to these non-renewable sources. And it can affect the economy also. So water splitting can reduce the emission of greenhouse gases. So CO2 emission can be reduced. If you are using gasoline, diesel, petrol, then CO2 is created and environment is harmful. So it can reduce greenhouse effect also. To break down this hydrogen and oxygen, there are various processes, various methods you can break down this. Electrolysis, photolysis, okay? Electrolysis, photoelectrochemical water splitting, photon, electric, chemical, chemistry, photocatalytic water splitting, radiolysis, photobiological water splitting, thermal decomposition, nuclear thermal chemical production. Various technique is there. Out of this technique, only photoelectrochemical water splitting is more promising technique. But why photoelectrochemical technique for the hydrogen production? Because based on the solar energy, which is a continuous source of energy, water is also a renewable resource. Like sun, we have also water. So water is available in large quantity. That's why when I told you, you prepare nanostructure, it should be low cost, easily available. Similarly, when you think about water splitting or hydrogen generation, the basic material, the raw material should be low cost and easily available. So water is easily available and environment safe with no byproduct. Therefore, when we use this photoelectrochemical technique with the help of water, it cannot create any kind of byproduct since the process occurs within the water. It may use on both large and small scale. So as I told, like small hydrogen production is possible. If you have this photoelectrochemical cell, you can make the hydrogen production quickly in a small space. And also you can make on larger scale. Now, what is photoelectrochemical water splitting? In the beginning, I explained you, photo means photon, okay, light, you understand. Electro, something related to electricity, okay. It consists of some kind of energy that comes through the electricity. Chemical, it consists of certain chemical. So, photoelectrochemical water splitting. Photoelectrochemical water splitting is decomposition based on conversion of light energy into electricity within a cell involving two electrodes. Okay? These are two electrodes, this one and this one. Immersed in aqueous electrolyte. So this solution is aqueous electrolyte. That is the water. Okay? We call as electrolyte. Of which at least one of made up of semiconductor exposed to the light. So one is made up of semiconductor and that is exposed to the light, okay, exposed to the light and able to absorb the light. In the photocatalysis, I told you that if you are making nanostructure, make sure that it should be sensitive to the light. So here, if you are looking for the good material, that material should absorb the light quickly. This electricity is then used for water electrolysis. Like when this light pass, the charge excite. Charge excite means movement of charge. So this charge initiated by this light, okay? The positive negative charge is excited by this light. So this way, there is a valence band, there is a conduction band, there are two electrode working counter electrode. So basically, how the process occurs, it is almost same like photocatalysis. Similar kind of oxidation reduction process occur. Electron can move from valence to conduction band, attract toward the electrode with the help of this light. In electrolysis, there is no light. In electrochemical, there is a light. In simple electrochemical, there is no light. Or electrolysis, there is no light. But this light excites this electron, and that's why this technique is called photoelectrochemical. So charge excited with the help of light, and then it can transform, okay? It can move, it can transport to the another electrode. So the movement of this electron is initiated by the light. And since this process is initiated by the light, we called it as a photoelectrochemical. This is the pure chemical reaction, oxidation and reduction. So I will not tell you the detail. Most of you is not from chemistry. Performance of these PEC cell, PEC photoelectrochemical cell. Excitation of electron in photoelectron. So how this electron is excited, that decides the performance. Separation of charge carrier, how these charge carrier are separated, okay? Positive, negative charge carrier. Electrode process and related charge transfer, okay? How electrons jump from one electrode to another. And this way, you can get the good performance. Generation of PVE voltage required for water splitting. So when this charge move, a certain voltage is required to initiate the water splitting. Once this voltage is acquired, the water gets split. H2O, hydrogen and oxygen get split, and there are bubble started to come out from the solution, and that bubble nothing but the hydrogen. The factors that affect earlier in case of photocatalysis, if you remember, semiconductor, concentration of semiconductor, light intensity, pH. Here, size, shape of nanocluster, what kind of material you have used, electrolyte temperature, solution temperature, pH, particle size and defect, okay? So here is also size of nanocluster, here is also size and shape of what kind of electrode you have used. One of the electrode should be made up of semiconductor or other type of material. If it consists of a certain particle size or defect, it will affect the photoelectrochemical process. Then band gap energy, also important. How much band gap energy? Because you are moving the charge carrier. And intensity of light, again same thing. So water splitting and photocatalysis are complementary processes. These processes are almost same, only the end result is different. In case of photocatalysis, our aim is to clean the water. Here our aim is to create the hydrogen, okay? So both application different, otherwise process are almost same. How we can increase the process of water splitting? Maybe you can have some kind of ion implantation on the electron, or use some kind of ion irradiation, or some bilayer system electrode you can replace, you can use another bilayer on the electrode, or some kind of dye sensitization you can use to improve the performance of hydrogen water splitting. What are the future challenge? So future challenge is to develop the efficient material or photoelectrode. In case of photoelectrode, you need electrode that is made up of either semiconductor or some kind of material. So those electrode material, that is photoelectrode. Why we call photoelectrode? Because it is sensitive to the light. That's why we are calling it as a photoelectrode. So that photoelectrode material should be very sensitive to the light. Optimization of synthesis route on large scale production. So when we are making this photoelectrode, it should be ready to make on larger scale. Integration of monolithic devices and single cell into two-dimensional array or grid for mass production of hydrogen. So when we succeed to get the hydrogen production, the challenge will be mass production. Remember, large production is different and mass production is different. Okay, mass means huge production. Large means large area. Okay, small means 1 centimeter by 1 centimeter. Large means 6 inch, 1 feet, 2 feet, 1 meter. And mass means bigger than 1 meter. Okay, large, giant, huge. And finally, evaluation of safety standard. So here hydrogen is evaluated. So when we are using the semiconductor material for electrode, that is photoelectrode, that should not create any byproduct or harmful substance during the water splitting. So those are the challenges in future. So we have to deal with those challenges while creating the future hydrogen production. So with this, I will stop here. Today I cover 2 topics. One was photocatalysis. I show you some of the real example, and at the end I cover hydrogen production. However, I have not shown you the example. There are various kind of material, mostly semiconductor material, are used for water splitting, because water splitting and photocatalysis are almost same or similar kind of processes. So now it is almost 10:55 or so. We can use few minutes for question if you have. Thank you. Questions? Any question on photocatalysis, hydrogen production? Yes? You means the evaluation of hydrogen cannot be stored. Yeah, that is one of the problem when you combine, your cell, how to extract the hydrogen, and loss of hydrogen should not be there because it is in the gas. So that is one of the challenge you have to deal. It depends on how your design is made, so that when hydrogen will be created, it should come out with higher production, and transportation loss should be less. So that is the question we need to answer, but the answer lies in the design. You should think about the design to extract how much hydrogen we can extract. Now, how you are collecting the hydrogen? By tube, how you collect the hydrogen? No. When your water splitting experiment is going on, okay, there is a hydrogen production. And your question is, you can...
there are some losses of hydrogen. So how can we overcome this problem?
So why your hydrogen losses is happening? Because of the design? Or where is the loss? Where it goes? From the solution, when it comes, you cannot get the hydrogen. Where that loss goes? In the design. So that's why I told you that when hydrogen is created, definitely there will be some loss. We cannot get 100%. But to increase the efficiency, it is our design, So that design, the minimum path should be there. Once hydrogen created, and this is our, collection. So that distance should be very small, so that it can, collect the hydrogen. You have to work on design, I think. Yes.
Sir, in the last slide, you told about the photo
This one? Future challenge? Sorry. Okay, just a moment. This one? Yeah.
You told about this two electrode system. You say
One should be.
one is exposed to light.
Because you will have one electrode. One electrode should be metal, because you are doing electrolytic process. So this voltage you will apply. So one should be like graphite or carbon or metal base, so that this process can be fast. And one can be semiconductor, because you are using the light. So when you use the light, we are in the search for photosensitive material. If this electrode is photosensitive, then process of production of hydrogen will be very fast. So that's why we are looking for some kind of photosensitive electrode.
So how can we distinguish between a counter electrode and working electrode?
So usually we fix one, counter electrode, and this working electrode may be chances that we can replace. This is optimization, which one is good, because we are dealing with the light, okay? So traditionally you can use two electrodes, steel, platinum, this one, okay? But since, like in photocatalysis, I told you we are using the light. And why we are using the light? Because light is the main component here to create the hydrogen. So if this electrode is photosensitive, then the process of splitting will be very fast. That's why we are looking for certain electrode material that can show better water splitting performance. Normally you can use, usually here platinum they use as a counter working. It is in your hand which you use. What kind of electrode you have used? Which working electrode you have used in your experiment? Nickel. And counter? Platinum. So both are metal to metal, right? Have you tried other beside nickel? No. Why we are trying this? Because remember, nickel, platinum, they are expensive. As in the laboratory, we are the one person. We will use only 1 centimeter by 1 centimeter or 2 centimeters for us. But when hydrogen production will be in the market, we want cheap and low cost material. Okay? This is not really taking into, but in future, when you will make the cell, that cell, one is platinum for sure, okay? But if you use nickel also, the price will be high. The price should not very high as compared to the gasoline or petrol. So that's why whether we can replace this working electrode with some kind of semiconductor material so that the cost of this device will be less. Okay. It's perfectly 11. Is there any question? Okay. Thank you. Thank you. I will stop here, and again I will see you in the afternoon for another class. Thank you very much.
Oxide, nanovoids by vacuum evaporation methods. He also holds an MSc in physics with a specialization in electronics and instrumentation and a BSc from Usmania University. Dr. R. Rakesh Kumar research focus on energy harvesting technologies like piezoelectric and triboelectric nanogenerators, as well as 2D materials, green hydrogen, IoT sensors, and self-powered devices. He has published 92 journal articles, 9 conference papers, and 8 book chapters, earning over 1,248 citations and a H index of 21. He also reviews articles for top journals such as ACS, Elsewhere, and Springer, so on, etc. In his career, Dr. Rakesh Kumar has held teaching and research positions, including as an assistant professor at Geetham University and NIT Warangal, where he was later promoted to associate professor. He has also been a visiting faculty at IISER Bhopal. He has guided multiple PhD and MSc students, with 3 PhD theses completed and 3 more ongoing. Dr. Rakesh Kumar has worked on prestigious projects funded by organizations like DST, ECR, and industry sponsors. Some of his notable projects includes a 50 lakh projects on Kelvin probe machine development and a 28.97 lakh project on flexible nanogenerators. His achievements includes clearing GATE with 90.6 percentile and receiving awards like the Teaching Excellence Award from NIT Warangal and the Best Award at the IUMRS ICY RAM 2016 conference. Dr. R. Rakesh Kumar is an active member of the Materials Research Society of India and the Indian Science Congress Association. His recent works focuses on advanced topics like sustainable energy harvesting, triboelectric sensors, and nanogenerator technologies, providing innovative solutions to challenges in energy and material science. His Google Scholar and ORCID profiles highlights his extensive contribution to research and academics. With this, I would like to welcome Dr. R. Rakesh Kumar sir to deliver his lecture. Thank you.
We are glad to have Professor Rakesh. He is my colleague, friend, and also fellow researcher. So very happy to see your growth, Professor Rakesh. Thanks for accepting to act as a resource person in our Gian program. And I would like to invite Professor Pankaj also on the stage to give a memento to Professor Rakesh as a token of gratitude. ఏం లేదా ఓకే ఓకే విల్ టేక్ ఓకే సో వెరీ గుడ్ మార్నింగ్ all of you. So very good morning all of you. Hope you are enjoying Gian course for 3 days. So today I will be talking about nano generators, new era of energy harvesting. I'm sorry. Yeah, I think it is fine now. So today I will be talking about energy harvesting using nano generators, as well as you are going to see some self-powered sensing applications. Okay. You must be curious by this time what is this LEDs are glowing, how these LED lights are glowing here. Are you curious or not? So it's a simple hand tapping, right? You are not producing anything, right? It's just a simple hand tapping. It's producing electrical energy from it, right? Yeah. So as you can see here, this is the simplest thing one can think of it about the nano generator. This is a small device. You can see it can fit in the palm. It is able to light up 4 LED lamps. You can see here about 100 LEDs are glowing with a simple mechanical energy harvesting. So what I am going to do here is I am going to convert mechanical energy into electrical energy by a means of a technology. So that technology you are going to see today, how the technology has been evolved and what are the physics principles behind it. If you want to develop such technologies, what are the things you must know it. All those things will be covered in this talk. So this is the outline of the presentation. So I'm going to start with what is the need for energy harvesting, like why do you want to go for the energy harvesting. Then we see the why you need a small scale energy harvesting, because my work will be mostly focused on small scale energy harvesting with triboelectric nano generator. Then I'm going to talk about what are the fundamentals which are required to understand to make a device. Then what are the materials we can use for triboelectric nano generators, and what are the possible application you can make out of triboelectric nano generator. This is the outline of presentation. So let's start with basic human needs. These are the basic human needs. One, everybody wants it, like security, safety, whatever you want. So you need anything else? This much is enough for us. This much is enough for us. You need anything more than this? Say yes or no at least. You need something more than this. What was that extra component? You need a Wi-Fi and battery. Your day start with Wi-Fi only, right? Your day start with battery, whether mobile is a battery or not. Agree, right? Everybody. If we go back to 20 years, this may not be the equation, because nobody bothered about battery charging, because Nokia mobile phone stands for 2-3 days. Okay. Nowadays that's not the case. Your smartphone you will discharge in a daytime. Not even daytime. If you start using Wi-Fi, it will be discharged very fast. So the idea is, now the generation has upgraded to an extent that you have to depend on energy. There is no other way. You cannot survive without energy. It can be a small scale energy, it can be a bigger scale energy. You need some kind of energy source. This is where
my research is focused here. So you consider two kind of energy systems. One is the larger scale, which is utilized for agriculture and industries, and there is a small scale. This you may be interested, okay? Because everybody is using a variable technologies, everybody using a portable sensors, trackers, GPS trackers, all those things. All those run with a small battery, okay? So for small battery, if the battery get drained, you need to replace the battery. Agree, everybody? You have to replace the battery, including this mobile pointers, this laser pointers as a battery. If this get discharged, you have to throw the batteries out. Maybe if you take your digital watch, whatever you have, you are having a batteries, okay? You are going to throwing them out. As a result, it's going to pollute the environment, okay? Especially this kind of waste comes from the batteries, going to pollute the environment. So we want to make a technology which will generate the energy from the environment so that these devices run on their own. They need not be charged again and again. They need not to be replace the batteries again and again. If you go to large scale energy, we'll be having hydrothermal, hydroelectric, nuclear, thermal, all those energy sources are available, which are there for quite long time. But this percentage around 59% from coal. But as time passes on, as you move further and further, maybe by 2040 or 2050, you are going to end up with most of the fossil fuel get exhausted. You need to find an alternate source at the earliest possible. Of course, we have predicted in advance that we need to improve our renewable energy sources to make our end needs, to make our life more dependent on the renewable energy sources than fossil fuel, because it's going to exhaust of some time. It won't stay for longer period. Okay. So as a result, we started exploring what are the other options for us. Like you have a solar panels, you have a wind energy, you have a tidal energy. Of course, the tidal energy still need to be explored to make it more efficient. These two are already established technologies. Solar panels were there for last 40 years. We are trying to improve the efficiency because this technology is almost stabilized. Like we are able to produce, sell it at a normal price in a local shop also nowadays. You can buy solar panels in a local shop also. So that's the technology we have developed. Maybe small efforts are still going on to make it more efficient solar panel. That is the only thing we are going in. So at this place, if you want to replace this all the fossil fuel, you need to just improve this more number of wind tunnels or more number of solar panels. And at the same time, you need to think about how to recycle the solar panels after their end life is done. After 15 years or after 20 years, you need to think about those possible problems. Okay. So we are happy with the large scale energy harvesting because we are able to produce good amount of renewable energy. So there is no issue at this place. So advantages, as I said, it's freely available, like if you consider sunlight and wind, and environmental friendly. There is no emission from carbon monoxide, carbon dioxide, and easily recyclable. Of course, this is not that easily if you consider solar panels, because it needs very precise recycling process. Okay. So this is our NIT Warangal main building, which is completely powered with solar panels. Now come to the why you need to have a small scale energy harvesting. As I said, one is you wanted to power your portable electronic devices, that is already there. If you want to think even more practical way, more serious way, this is a possibility. This is a place where you need small scale energy harvesting very badly, very needs. If you consider these implantable medical devices, especially if you take a pacemaker which makes heartbeat proper in number, okay. All these implantable medical devices are insulin pumps. All these are implanted into your body, which runs on the battery. Okay. Suppose if you take a case of a simple pacemaker has a battery inside. If you are going to insert into the human body, and this will give electrical pulses to the heartbeat whenever it goes to a minimum level. Okay. So after some time, this gets drained up. This battery gets drained up. Then what you are supposed to do? You have to make another surgery, take that out, replace the battery, and put it back. The person like you and me, it is kind of okay because we are young to have to go to second surgery. But if you consider a person who has more than 55 or more than 60 and all, they will be having other issues, maybe blood pressure issues or sugar issues. They may not. That's not easy case to go for a second surgery. It may be a risk for the patient also. So, but if at all, if you harvest some energy by some device which can power this device automatically from the human body, then you don't need to replace the batteries at all. The battery will be recharged by the human motions and it will run for indefinite time. The only thing is you have to do only one surgery, which will just implant your medical device. So this is a place where you require small scale energy very much. And also if you consider this kind of bridges, okay, suppose you put one sensor here which is battery powered. Suppose the sensor stops sending the signals, or maybe it may be railway track condition, whether the track is proper or not. Now the battery is gone. Someone has to go here and change the battery. It's too risky. You cannot go every time and change the battery. Okay. So if you can make use of this vibration energy from these tracks, if you can convert, if you make one device here which can power those sensor indefinite time, then you don't need to replace the batteries at all. So this is what I am trying to do in my research work. So this is where your small scale energy comes into picture and make an impact on our lives. So to do that, we have several nano generators. Why we call this nano generators? We are going to generate a small amount of energy. That's why we call them as a nano generator. Sometimes people use nanomaterials in making these devices. We call them nano generators. The first one is a pyroelectric and second one is a thermoelectric. These two are based on the heat to electrical energy. Wherever there is a waste heat energy, we can convert them into electrical energy by the normal Seebeck effect in this case. In this case, orientation of the dipoles with respect to the temperature change. This is not my interest because this is very uneven conditions, because you need to maintain the temperature difference accurately. It's not always possible, but whereas my interest is here, piezoelectric and triboelectric nano generator. Here these two devices will convert mechanical energy into electrical energy, any type of mechanical energy. The advantage with the mechanical energy is you have mechanical energy everywhere. You're walking, running, jogging, worst case your heartbeat also mechanical energy, your blood stream flowing through veins also a mechanical energy. So there are a lot of mechanical energy sources available around us, which are freely available, which are going waste. We wanted to harvest those mechanical energy to make the electrical energy. So these are the two effects. One is the piezoelectric effect, other one is the triboelectric effect. This is done by Professor Jidal Wang from Georgia Tech in 2006 and 2012 respectively, both the technologies. As I said, you have mechanical energy everywhere, right? Infrastructure, transport, industry, environment, you have everywhere mechanical energy available. Only thing is you need to make a device which can take that mechanical energy and produce the electrical energy. So let's start with the simplest case. Piezoelectric, this you must have studied in your school level and your college level, where there are certain kind of materials, typically non-centrosymmetric crystals, okay, where centers of positive and negative charges are not coinciding with each other. So those materials, if you apply a pressure, something like this, so the center of positive and negative charge will not coincide. As a result, you are going to have a potential difference across the two surfaces. Okay, so that piezoelectric effect, taking any mechanical energy which is applied on the substrate from the top side and going to produce the electrical output. So this is one, but the disadvantage with the method is you do have a limitation on the material choices. You cannot use whatever the material you wanted to choose. You have to choose a material which will satisfy the non-centrosymmetric crystal. So typically like zinc oxide, P80, barium titanate quartz. These are very limited material choices. So if you want to improve something or if you want to develop something, you do not have many material library. We have to play along with this only material. So as a result, this is kind of area of research which is not progressing very fast, but still people are making efforts to make a more sensitive piezoelectric nano generators. Now come to the triboelectric nano generators. So triboelectric nano generators, if you want to understand, before that you need to understand what is meant by static electricity. Hope you must have encountered this in a lifetime, at least once in lifetime. When you touch a door handle, you must have got the shock, especially metal handles like copper or stainless steel handles, because typically in winter time there will be a lot of static charge deposit on these metal surfaces. When you touch them, there will be a conducting path. As a result, you are going to get a sudden shock. Okay, and similarly, if you consider other case, your lightning also comes from the static electricity, which is decorated on the clouds of clouds. And the static electricity is not good for your CMOS ICs or your integrated circuits. Okay, so basically what I'm trying to tell is the static electricity is not a good thing for us, but triboelectric nano generator going to make this unwanted effect into useful effect for us. We are going to make this unwanted static electricity effect into useful product to make energy harvesting. You can see here this is a Van der Graaf generator where electrons are passing from this generator to this human body. Since both are electrons which are charged on the hair, both get repelled each other. As a result, your hair get flipped up exactly like this. Okay. So this is the effect what we are going to use in triboelectric nanogenerators. So you can see here the first phenomenon in triboelectric nanogenerator is the contact electrification. It is everywhere, it is available everywhere. When you rub two materials, based on their electron affinities, one metal get positive charge, one metal get negative charge. That's what happens when you rub a balloon with a air, or when you take a charged object to another charged object. You can see here now scale is rubbed, it is charged with some charge. Now you can see it is giving a pushing force to the paper. So this is the contact electrification, where two material comes under a contact, and because their electron affinities, or because of the difference in their work function, they exchange the charge carrier. That means one will be giving the electron, one will be accepting the electron. As a result, one become positively charged, one become negatively charged. So this is the first principle we are going to use in triboelectric nanogenerator. And second one is the induction phenomena, electrostatic induction. Induction means when there is already charged object, if you bring charged object close to another object which is not uniformly distributed. You can see here this is a charged object. Moment you keep it here, you can see the charges are getting redistributed. As a result, you are going to see some free electron which can flow across the electrodes if you connect some electrodes to that. So these are the two phenomena we are going to use. One is a contact electrification. You require two material to be contact each other, and there if you, when they separate up, there will be induction phenomena. Okay. So these are the two principles on which we are going to make our triboelectric nanogenerators. This part we have discussed just now. Now let's start with what are the components of the triboelectric nanogenerator. As I said, if you want to make a triboelectric nanogenerator, you need two layers. One is positive triboelectric layer, other one is a negative triboelectric layer. It is, you can name it other way around. Typically you need two arbitrary layers. One supposed to give electron, one supposed to accept the electrons. What we do is we attach those two materials to two electrodes, and this entire setup will be placed on an acrylic board. It is a non-conducting surface, and this also going to place an acrylic board, and we are going to place it one over each other with a some small sponge spacer, like you can see here. This yellow color is one triboelectric layer or one positive layer, and this white one is another triboelectric layer. And if you put this upper one to the down one, there will be a sponge across the four corners. You will be having a finite gap between the two friction layers. Hope this is clear for everyone. Is it clear, everyone? Because if you clear only, later slides will be understood, otherwise it will be confusing. Okay, so what we are going to have is, we are going to have two frictional layers with a spacing between them, and if you apply the mechanical force from top side, something like if you apply from the mechanical force, this layer will come and touch with this layer. When you remove the force, they will get separated automatically. You don't need to separate them with a manual thing, because this sponge elasticity will make them separated out. So in a two-dimensional way, you can see something like you have two frictional layers with two electrodes contact with each other. Now you are going to connect your measuring device here to measure either current or voltage, whatever you wanted to measure it. Hope this is clear for everyone, this slide. Yes. Now how do you select the materials? So as I said, you need two materials. We have a triboelectric series here. This is standard series. It's still this upgrading. Here what we do is we we put them the materials according to their electron affinities. So if you look at this green color table, these are the material which has more positiveness. That more positive metal means they are ready to give electrons as much as. Okay. So this material has the most electron donating capability compared to this last one. Similarly, in this case, this last one, the silicone rubber has more electron accepting nature. They take as many as electrons they want, and this has a lesser electron affinity to take the electron. So if you choose this extreme end material and this extreme end material, you are going to have more potential difference, because this is going to give more electrons, this is going to take more electrons when they touch each other. Okay. So you have to choose these materials such a way that you should have maximum electron affinity difference. In a simplest case, you can consider the maximum work function difference. Okay. So this is only list prepared by the standard materials. We have n number of materials. You can choose any material here, because at the end of the day you need two materials which has a two different electron affinities. That's the thing. You have a good amount of choice to select any arbitrary material. We are going to see all the materials also in today's lecture. Now what is the working mechanism? So this you have to stay focused and stay attention. You can see here, this is the starting condition. When the two layers are separated from each other, there is no potential difference, there is no current in the circuit. When they touch each other, one is giving the electrons becoming positive, one is taking the electron becoming negative. Now contact electrification has been taken place. After you apply the force from here, this layer touched here, and we have a contact electrification between the two layers now. Okay. Now when they start separate, when you remove the force, they start separated because there is a sponge spacer here. This sponge spacer push them up. When the layers separate up, there is a potential difference. Okay. To this potential difference drives the electrons from bottom electrode to the top electrode, so that this potential difference get nullified. So you are going to make it stable condition or equilibrium condition. So if your electrons travel from here, there will be induced positive charge here, there will be negative charges here, this will get neutralized. That means it's like a equilibrium condition. So during this time, you are going to get one current pulse in the circuit. After it gets equilibrium state, when you are going to apply once again force on this device, they are coming closer together again. When they come closer together, the potential difference will decrease. Now whatever the electrons which are flowed in the previous case, they will again travel back to the previous electrode. In that case, you are going to get another small current pulse in the circuit. As you can see in the animation here, animation is not playing, I guess. Let me play once again. You can check out the animation once again. Yeah. So now there is no charge. Now contact electrification is taking place. One is positive, one is negative. When they are separating up, you can see electrons are flowing, and there is a positive charge is in, there is a negative charge. Now first peak is generated. When it is coming down, the electron will flow back. You are going to see the negative peak in the. So at the end of the day, if you keep on tapping the device, you are going to have alternating current or alternating voltage in the circuit. That current and voltage utilized for powering the LED lamps or LEDs, what you have seen in the first slide. You have seen, right? Some hand is tapping the device. So this electricity produced by the device is powering those LED lights and LED lamps. So this is a working principle of your triboelectric nanogenerator. This is one mode of operation. This is called vertical contact separation mode. We do have other modes like lateral sliding, where your two friction layers will move like this. Instead of like this, they will move like this. Or and sometimes you can also have a rotational thing, where two layers will be rotating like this. And the last one is the single electrode mode. This is most useful thing. These two are the most useful modes for the TNG. This for mechanical energy harvesting. This is for the sensing application, where this material can be even hand also. Hand also can act as a material to touch the electrode to get the contact electrification. So these are the modes of your triboelectric nanogenerator where you can design your nanogenerator. So this is what happens when you bring two materials closer. There will be electron cloud overlap on each other. So when they come closer and closer, the electron jumps from this cloud to this cloud. When they separate out, the electron cannot jump back, so they will get separated out. As a result, one become positive, which has given the electron, and other one become negative, which has took the electron. Now what are the parameters which affect the TNG output? As till this point we are clear. If you want to make a triboelectric nanogenerator, you need two frictional layers of two different electron affinities which are attached to two electrodes, which will be connected to a wire which measure the current or voltage, and you have to repeatedly apply the mechanical force to make them contact and separated. Okay. Now what are the parameters? As I said, first one is the work function difference, or you can say electron affinity difference. The more the difference, the better will be the electron transfer, you are going to get the better output. And surface contact point, even though if the potential difference is more, if the contact points are not more, this surface has only 10 contact points, you get only 10 electrons get transferred. If there are 100 contact points, 100 electrons will transfer. If there are 1000 contact points, 1000 electrons get transferred. So more the contact point, more the charge generation will happen, and how much surface charge density it can hold, how many induced electrons can hold it back. Then you are going to have dielectric constant, which is nothing but again storage of the charge. Dielectric is nothing but again. So these are the material properties which need to be taken care before you make the device. And coming to the device parameters, so you can have other different parameters like what are the force you are applying on the device, whether you are applying a 5 Newton force or 6 Newton force, that is the first thing. And the second thing is the frequency of the applied force, how fast you are applying or how slowly you are applying the force. And the spacing between the friction layers, whether it's too spaced or only very closely spaced, and what is the testing environment, whether you are testing this device under normal conditions or humidity conditions or temperature conditions. So all those things will affect your TNG output. Now what are the devices we use for making this device characterization? Once your device is fabricated, you need to measure the current, you need to measure the voltage, you need to measure the charge, you need to measure the work function, you may need to measure the dielectric constant. Okay. So these are the instruments. You can use oscilloscope for measuring the voltage and current amplifier measuring the current, or you can use any source meter from Keithley you can use to measure current, volt, and this is the electrometer which can measure both current, voltage and charge. And this is a Kelvin probe microscope which is used for measuring the work function of the material, whether the material has more work function, less work function, and this is the AFM to measure the roughness of the material. So this information will give you how many contact span can take place when two materials are attached to each other. And there is LCR meter which will measure the dielectric constant of your triboelectric materials, and there is electrostatic voltmeter which will measure the surface potential of your triboelectric layer. So these are the instruments which are required to characterize your triboelectric nanogenerator. Now we'll go to the fundamental physics. So if you want to understand the fundamental, you have to go back to the Maxwell's equation. So if you look at this Maxwell equation, this is for electromagnetic induction, rate of change of magnetic field produce the electric field. And there is Ampere's Maxwell's law. This is where our triboelectric nanogenerators comes into picture. If you look at the Ampere's law, this is what Ampere's law states. When current passing through a metal conductor, you will be having a magnetic field around it. And thus we call it the del cross B equals mu 0 times J. This is valid for some time. And then after that Maxwell's came into picture and said that this equation is not valid. If you consider the capacitor case, if you consider parallel capacitor case, so when you charge the capacitor, there will be a conduction, there will be a current passing between the two capacitor plates, that we call them as the displacement current. That is happening because of time dependent electric field, dou E by dou T. When the capacitor is getting charged, you are going to have rate of change of electric field between the plates that will produce the current in the magnetic field. So as a result, so till this it was there, this extra term was added because when you have a capacitor case, you have to consider this term. Now after this, there is one more correction happened for this equation. That is where our nanogenerators comes into picture. So this is the actual Ampere's law, then Maxwell added this term. Now nanogenerator is going to add one more term for the equation. What is that? In both the cases, either it's a piezoelectric or triboelectric nanogenerator, what you are doing is you are separating the positive charges, separating the negative charges. It's nothing but a polarization. Polarization means having the same kind of polar things, like either completely positive or completely negative. If you consider both the cases, you can see you are separating the negative charges here and positive charges here, similarly here also. So you are doing something like a polarization. There is nothing but dou PS by dou T. Rate of change of polarization with respect to time it is happening. So because of this rate of change of polarization, you are going to see current in the external device. This extra term should be added to the Ampere's Maxwell's equation. So if you rewrite the equations, you are going to have something like this, where your displacement current will be dou E by dou T, this comes from the capacitor, and dou PS by dou T comes from the nanogenerator. So this is the physics you need to understand if you want to understand about triboelectric nanogenerators properly. If you want to compare electromagnetic triboelectric, it's as simple as, in case of electromagnetic, you do not have any material choices. I mean, like, you have to use only iron core with what are the standard metal, whereas in triboelectric, you can use as you want, whichever the material you wanted to use, provided as long as they are not same materials. Okay, and this works at higher frequency. Your triboelectric nanogenerator works at the lower frequencies. Like we can work this nanogenerator at 1 Hz, 2 Hz also, but this will work at typical higher frequencies. You don't produce, the more the change of magnetic field with respect to time, you are going to get more current with the electromagnetic generator. Okay. Now come to the material choice. Now what are the materials we can use? What are the materials can be explored to make this kind of device? You can see here there are n number of materials already explored in the literature, right from oxide materials, metals, semiconductors, porous material like metal organic framework, dielectric materials. Some of them used waste materials, some of them used polymers, some of them used high temperature oxides, some of them used 2D layers like graphene, carbon nanotubes, or MXenes and all. Okay, I'm going to show you a few of the results which we done at our laboratory. We'll start with the zinc oxide. So in this work, we have synthesized zinc oxide nanosheets and aluminum by simple hydrothermal method, where your plain aluminum is coated with zinc oxide nanosheets. You can see these are the zinc oxide nanosheets and aluminum substrate. Now we made a device keeping zinc oxide nanosheets as one frictional layer and opposite as a PDMS as other frictional layers. So when you tap this device, we could able to produce, we could able to produce around 1000 volts and 150 micrograms current In TNG you get huge amount of voltage, but it's only pulse voltage, it is not a DC voltage. So it stays for a few milliseconds, it won't take much time to get back to zero. And we have done a load characteristics for the device where we varied the load resistance and measured the TNG output voltage and found that at 10 megohms it is giving the optimum response or optimum power, which is around 10.8 watt per meter square. This device we used for powering the electronic devices. Typically in case of this thing, we are powering this digital watch here, you can see in the video. It's not playing, I guess, let me play fast. You can see now, this is a TNG device. This TNG is tapped by the hand and there is a full wave rectifier here and there is a capacitor, the capacitor getting charged. After capacitor get charged to certain level like 1.5 volts or 1.2 volts and your digital watch gets on, as long as this tapping is there, your watch will run without any battery. This is what we were trying to do. So now this is self-powered. If you put this TNG device, if there is a mechanical energy source, that mechanical energy source will tapping the device and your digital watch will be running continuously without any break. So this becomes a self-powered system. Okay. So this even calculator also we will be able to run. So we just made it little, because it takes some 1 to 2 minutes to charge the capacitor to desired level. Now you can see your calculator is running without a battery. So this is the first application we have explored, powering the small portable electron devices. Later we want to use same device for powering the pacemaker or powering the insulin pump. So based on the power requirement, we need to do some additional modification in the energy management circuit. Now we explored later MXenes, which is a 2D materials, where we have take max phase materials of, we have many libraries for max phase. So out of which we have taken titanium aluminum carbide. So we mixed with silicon solution and we made a composite film. As you can see here, this silicon mixed with MXene sheets of titanium carbide and we made a composite film. This is a device geometry. When we tapped this device with the hand tapping, we could able to produce around 370 volts without MXene, and with MXene we are going to produce 600 volts, and power density without adding MXene to the silicon we are getting around 5 watt. When you add MXene we are getting 15 watt per meter square. Typically these MXenes are negative in nature, they have triboelectric negative nature, and your silicon material also triboelectric negative material. When you add one negative material to the other negative material, its negativity will improve a little ahead. So as a result you are going to see improved performance from 5 watt per meter square to 15 watt per meter square. This we used for different application I am going to show you, and later we explored double layer hydroxide with the MXene sheets. Even we have improved further to almost 35 watt per meter square, and we have explored this for lighting the LED lamps, as you can see here. So with the simple hand tapping, so 2 LED lamps are able to glow. And this security application we have made it. So in this case what we have done is we have utilized our TNG in the single electrode mode, where your hand acts as one friction layer and your MXene silicon acts as another friction layer, and we connected output of the TNG to a Arduino board with a blink cap. Okay. Whenever someone touches the MXene surface, you are going to get electrical pulse. That pulse will be read by the Arduino board, will send an SMS that someone has touched my door handle. Suppose you attach this TNG device to a bureau or maybe a locker. If someone trying to open, you are going to place it here. Whenever someone touches, then there is a triboelectric effect, there will be electric pulse. That pulse will activate this Arduino board to send SMS to your mobile user. Okay. We have implemented it. I am going to show the video now. You can see here. So we are touching with hand, we are attached to a small woven. This is a woven door. You can see woven door is adding a triboelectric layer here. Now blink app will give you a message that some unauthorized access has been taken place. Okay. And if you open the message, you can get the information about when the access was done, at what time, how many attempts has been done. Everything can be done with the Blink Cloud app. It takes few seconds, so you can see now it is received. Now you can see its time, everything is detected, and date, everything will be done by the Arduino boards. This is with hands. Suppose someone cleverly uses a gloves, but still gloves also triboelectric material. Still you get the alert to the user. So it doesn't matter whether you use a hand or gloves or anything, until unless you use a paper. paper is electrically neutral some extent. Okay. Otherwise, most of the cases you will get the alert. So this is a more secure system than anything else. So this is a touch sensing for security applications. Later we explored metal organic framework. This is a class of materials where you have a lot of porous structures, okay, where you have a metal, ion and organic linkers. With this you get different kind of morphologies which will be useful for us. And in addition to that we are going to have functionalization. This is the extra thing where metal organic frameworks will be having, where you can functionalize the metal with electron donating groups or electron accepting groups. If you want to improve the negative property, you can attach the electron accepting group like fluorine, chlorine. Okay, if you want to donate the electron, you can also use NO2, NH3, like that you can use it. So previously the MOFs are used only for catalysis, magnetism, other things, but we have used it for the energy harvesting application with a new field. First we start with a GIF 67. This is Geolite Immunogeol Framework. This number comes from the university, sometimes comes from the place, sometimes comes from the scientist name. Where we have done is we have synthesized the MOF by simple hydrothermal method, then we mix with some PVA polymer solution, then we made a composite film, then we made the TNG device with GIF 67 as a active friction layer. So this is producing around 70 milliwatt per meter square. The power density is quite small which compared to other reports, but it depends on the material property that need to be improved. And we use for powering energy harvesting tiles. If you look at this application here, so we have kept 4 devices here and someone is stepping on it. You can see almost like 600 LEDs are glowing for a single footstep. So you can make set of tiles here, make in a footpath, you can make energy harvesting tiles. And similarly you can also see here this LEDs which are organized in a typical pattern. If someone presses them, you're going to get this LEDs are on and off. This will be used for indicators. Suppose in a building, if you want to put a, yes please. Yeah, it depends upon the mechanical strength of your material. Suppose your metal is brittle, then you may not use higher force. But typically we don't apply excess force because we are interested in biomechanical energy, like what human can apply the force.
Minimum force
No minimum force. Even if you want to use for sensing application, even if small touch also enough. Touch also, you need to apply forcefully also. Ideally you need to just make a small contact, that's all. If the contact force is more, you are going to get more contact area. You may get little increased signal, nothing else. Because if you look at the outputs here, if you go back and look at the output here, you are getting 100 volts peak, right? If you touch it, you may get 15 volts peak. That is more than enough for the Arduino board to read and send the signal. And we are done with MOF 303 metal organic frameworks, where we directly synthesized metal organic frameworks on MOF 303 here, which is a plain aluminium, and this is MOF 30 coat aluminium, and this is the device geometry, where FEP acts as a opposite layer and MOF 30 acts as another opposite layer. And we could able to get power density of around 7.8 watt per meter square, and we confirmed that this particular metal is tribo-positive material, because most of the materials are not known their tribolexity, because only we have a standard series of material. Other material need to be confirmed whether it is a tribo-positive or tribo-negative. So with this work we have confirmed that this metal is a tribo-positive material. And we use it for powering 4 LED lamps here. Probably this video is not playing, I will just play it quickly. Now we improved so that we could able to power up 4 LED lamps, you can see now. And we also used for cell power indicator. This is an interesting application developed in our laboratory. What we have done is we have put TNG devices near the footrest, where you are going to change the gear, apply the brake. And we have put 2 more at the near the handle at this place, near the handle. So when you take a turn left or right, this TNG get pressed and you are going to get the automatic indication. You do not have any battery to tell that I am taking a turn. The moment your handle is slightly left or slightly left, immediately the light which is at the back side, suppose in this case you are taking a left turn, you can say left light LED, this lamp is on. In this case right turn, this LED is on. Or else if you want to, let's say, take a left turn, right turn, you want to give advanced indication, you can always press this TNG device 3-4 times with a leg. It will give an indication that I am taking left or right. So I have a video, I will show you now. You can check out this real-time video that we have recorded in our department. So you can see this is the TNG at the footrest, and these are the 2 LED lamps which are connected through the wires, and this is another TNG here. this place. If someone tap on this device 3-4 times whenever you want to take a left turn or right turn based on his interest, you can see now he is tapping the device here and you can see there is a clear indication. So this technology will completely remove the, completely overcome the issues with the indicator problems. We don't need any battery right now. So if you put this technology into all the motorbikes and all, people can use this without any batteries. Even if the battery is not there for the bike, still you can give the indication whether you're taking left turn or right turn. So this enhances the safety for the vehicles or avoid the road accidents and all. Yes, please. Yes, handle will give the indication, but that will give you only once. If you are taking only, it will press only once, means you will get only one thing. But if you have a, if you tap the near the leg, it will be more easy. You can give multiple indication that I'm taking and all. If someone is not very attentive, this may not be a good idea, but this will be a good idea. You can tap 3-4 times, people can see that they're taking left or right turn. Okay. And later we started using the waste materials for nano generators, where we have explored some medical waste, as you can see here. We start with simple saline bottle. As you know, most of the time these saline bottles all get wasted, sometimes burned outside the hospital. Okay, what we have done is we take a small piece of saline bottle. This is nothing but a small plastic piece, and we made one as a saline bottle as one frictional layer, opposite as a silicone layer, and we could able to achieve 8.7 watt per meter square, where we have used for powering LEDs, as well as sleep monitoring and touch sensing. I'm going to show you the videos in a moment. And this is a small piece which cut from the saline bottle 5x5, and this is the device geometry, and this is the output you are getting from the TNG. And you can see the stability is almost 3 months also it is stable. After 3 months also we test the device, still you are getting the stable output from the TNG device. So in this case we have explored a new application for sleep monitoring. So this looks very silly, but actually it's a serious issue. People who doesn't get sleep in the night sometimes. They get sleep maybe 10 to 11, maybe 11 to 3 o'clock they may not able to sleep. They will be just simply rolling on the bed or left, right, moving up and down. Okay. So this is a serious issue. Okay. So how do you monitor that? You have to put some sensor in the bed and to monitor it. That is the only way you can do it. So what we have done is we have implanted our TNG device in the pillow. And okay, so the person who is in the photograph is myself. I am the one who has done this experiment. Okay. So this TNG is implanted, 2 electrodes are taken, I connect to the oscilloscope. When the person is sleeping peacefully on the pillow without any deviation, the oscilloscope will show the stable DC value, 0 volts, whatever it is. Moment there is a disturbance, whether you're moving left or right, upside down, all those things, there will be a disturbance. As you can see, there is a disturbance here, there is a disturbance here, there is a disturbance, there is a big disturbance because I completely flipped upside down. Okay. So same thing here. So if you record the entire night, and next day morning if you look at the peak pattern, you will understand that at what time you have a sleeping issue. You may not have time to go and see your watch, what time it is and all every time. Okay. So this is a good example of triboelectric nano generator for sensing application. As you can see in this video. So this is now peaceful sleep, no spikes in the oscilloscope. Moment I start moving left or right, you can see a small spike here immediately. Very fast. The response will be, because you're getting a lot of high voltage pulses, even small disturbance also will give a pulse in the oscilloscope. If I change drastically, completely upside down and all, you're going to have more. So now you can see the peak is more distinguished. Okay. So if you record this signal, you can monitor the sleep of a person, how peacefully he has slept in the last night. And we'll go to the touch sensing application, where we have used a single electrode mode. This is a simple touch sensing application. As you can see here, it's a single finger touch. You can see there is a nice output pulse are coming out. This with one finger. If you add 2 fingers, it will be little multiplied. You can see the output magnitude is changed. If I go with the 3 fingers, it will be even bit more. Now it is bit more. So this is used for touch sensing as well as the force sensing also. If 1 finger there is a little lesser force, 2 fingers little more force, 3 fingers will be even more force. So you can use for touch sensing as well as force sensing application. And we also use the X-ray sheets. Nowadays it is almost digital now, but still some places still people use X-ray sheets. We can also use X-ray sheets. And this other works where we have done printer cartridge. If you look at this Canon LBP 2900 model cartridge, so this most of them will throw away. Once if you will refill it 3-4 times, if it doesn't work properly, we'll throw them away, that entire thing. But if you open carefully, there is a OPC drum, which is in blue color, which is a charge storing layer actually in printer, where ink is attached, ink particles will be attached to here and going to print on the paper. This actually aluminum tube which is coated with some polymer layer. What we have done is we have taken this tube and made it a flat sheet, and we made a device out of it, and we could able to produce 4.6 watt per meter square with this electronic waste. And same with seashells, we collected some seashells from the near seashore in Vijayawada, and we made a powder out of it, and we made a device out of it, and it's also produced good amount of voltage and current. And we have used for respiratory monitoring. Suppose you want to analyze a breath pattern, how the breath pattern is taking place. We have implanted TNG device here near the chest. As he breathes, you are going to see pulses in the oscilloscope. Yeah. Sorry, video got stuck. Okay, fine. It got stuck. Sorry. Yeah. Now we move to nanofibers, where we have done simple nanofibers since the electrospinning machine, where we have done GIP67 with some PVA solution, and finally we made a nanofiber mat with the electrospinning machine. So this experiment we are going to demonstrate in the afternoon lab, where you are going to see electrospinning machine, how fibers are made out of electrospinning machine. So after that nanofibers are made, we have sorry, it went very fast. Yeah. Oh, so fast. Yeah. So these are the nanofibers which we synthesize without GIP67. This is with GIP67. These bubbles are where GIP67 is embedded into the nanofiber, and we got around 11 watt per meter square as a power density for this particular nanofiber mat. And we use this for smart hygiene system. So most of the time, this washroom, especially maybe railways or in public places or hotels and all. So someone has to go and check whether what is the condition of the bathroom, whether it is cleaned or not, or how many times it has been used. We have to monitor it manually. So instead of doing that, what we have done is we attach a small door sensor, which is nothing but a triboelectric sensor here. Whenever the door opens and closes, there will be one electric pulse coming to the Arduino board. So this Arduino board, which is powered with a small battery here, this Arduino board will send signal to the mobile user whenever door close and open by 10 times or 20 times based on the user. Someone who uses bathroom, one count will be counted in the Arduino board. Whenever it reaches the count, maybe 10 or 20 count, it will send a SMS to the user that washroom has been used enough number of times, it times to clean the washroom. Okay. So as a result, you don't need to monitor the washroom every time. So it automatically sends whenever the required number of usages are done by the users. This is another explored with a simple thing. Probably I'll show the video, you can see here. So this is one triboelectric layer, and this is another triboelectric layer, which are connected with a small electrode and all. So the small wire which is coming to your Arduino board, which take the electric pulse coming out of your triboelectric nano generator. Now we are going to close and open the door 10 times or 20 times based on how you program your Arduino board. Now you can see it is counting the number. Moment it reaches 10, it will send a SMS to the mobile. Mobile automatically receives mobile SMS from the Arduino board, which has inbuilt Wi-Fi module, which connect through. Now when 10 reaches, he will give, now SMS is received that washroom has been used 10 times. Now it's time for cleaning. So this one, another application we have used it. And we have further explored PASPER based TNG. Professor Arnath must have told about many PASPER material in the last lecture, I guess. Fluorescence, luminescence, afterglow PASPER, all those things. So we took some material from his laboratory, which is vanadium pentoxide, zinc vanadate. So this we have used as one of the friction layers. We could able to generate a power around 7 watt per meter square, and we are also able to power on one electroluminescence device with this. And further we also take another PASPER, which is a tritium based European doped tritium, which used for UV light sensing. In presence of UV light, what is the output of the TNG, and in the absence of UV light, what is the output of the TNG. We can clearly see that there is a distinct intensity in the in presence of UV light, without presence of UV light. So this we can use for a UV light sensing application. And this we have explored for smart parking application, where what we have done is, so typically if you go to any shopping mall or any public place where there may be many parking slots, but you don't know which parking slot is free, first thing. Whether parking slots are available or not also we don't know. So to overcome that problem, what we have done is, for example, we have taken 4 parking slots here, and under this 4 parking slot we have put our TNG devices. Whenever car parks into the slot, this TNG get compressed and give a signal to the Arduino board. Arduino board will give you a display that this particular slot is occupied. Okay. So similarly, whenever you take out the car, they get separated out, then that will give an indication that that particular parking slot is vacant. So this way we can display like this. If you look at here, there are 2 parks are parked and 2 are outside. Now you can see there are 2 red, 2 green. That means 2 red are occupied and 2 green are free to occupy. So this is a kind of visual indication at the outside the shopping mall or near the parking slot, where user can see which parking slot is free, which parking slot is not free. You can see in the demonstration here. So this is a TNG device. You can see the sponge spaces, everything. And such 4 devices are placed here, 1, 2, 3, 4, and you want to cover with a small cardboard. Now this is the Arduino board, which is take the signal from these 4 TNG devices, which is programmed with a small Python code. And this is a display where you are going to have your display, which parking slot is free, which parking slot is occupied. As you can see here, I can see here whenever the first car comes, you can see this is in, this parking slot is filled. Now 4th one is filled, then 2nd one is filled, then again you can see here now all 4 are filled now. Moment if you take out the car, then the particular slot becomes free. Now this is free, and 4th one is free, then other one will be free as long as you remove the car. So this is a kind of indication to the user that this particular slot is free. Then further we have used some gel-based materials from chemistry department. Professor Nagarajan sir has provided some supramolecular gels. We have used this making a humidity sensing application, where we have used for measuring the humidity in the environment. We have tested our device under different humidity conditions like 70% humidity, 80% humidity, and we could clearly see the device able to sense the humidity levels and producing the different output voltages depending on the humidity levels. Whenever you want to measure humidity, you can use this TNG device for humidity sensing application. And this is the most interesting and potential application from our end. We have used this TNG for hydrogen generation. Now everybody knows hydrogen technologies. People are investing crores of money to produce hydrogen based cars. Because when you run hydrogen, when you run a car with hydrogen, you are going to end up byproduct as water. So it is a pollution free. That's what people are focusing hydrogen. So what we have done is, we have used this I think Pankaj sir must have covered electrocatalysis just few years, right? You need some power source to activate this electrocatalysis. The power comes from our triboelectric nano. As simple as this setup will be same. We are not going to change the setup. I'm going to change the power source. Instead of giving from a power source, I'm going to give a TNG, and these 2 friction layers get contacted each other. Then the current will be produced. The current will be given to this system, and the electrocatalysis will take place here. And one place you are going to get hydrogen gas, in other case you are going to get the oxygen gas. As you can see in this screenshot, from 0 minute the water level is here. As the time progresses, you can see water level is coming down. That means hydrogen gas is generating and going up. Probably I'll show the video. Video is available here. Yeah, you can see here. Can you see bubbles are going up? Small bubbles. And this water droplet level will come down as time passes on. This is the level of the water. You can see it will come down. So this, the output will be generated by your any mechanical motor to run it. In later application we have done self-powered electrode deposition. So if you want to coat this key with a copper, so you take a copper sulfate solution in the copper as an electrode, and you are going to get TNG output as energy for this electrode deposition. We don't give any battery here. The energy comes from the TNG device, which is tapped by a machine here. Instead of hand tapping, you are using a machine here. The energy will come through here through a rectifier and applied to this electrode system, and electrode deposition will take place, and your key will be coated with copper. So electrode deposition of copper will be taking place on the, so we had run it for around 10 minutes of tapping. But this just only show the potential of this technology. You should not tap with the machine ideally. You should tap with some available mechanical source. You should not provide any mechanical source by some power. So we run around 10 minutes. Probably this video will go ahead, little ahead. Still low. It's playing. It will be stopped in a couple of seconds. Yeah. Another 1 more minute. Now you can see the key from that solution. It will be coated with copper nicely. Can you see all of you? Yeah. So this is a self-powered electrode deposition with the triboelectric nanogenerators. This we have demonstrated in our laboratory. And later these nanogenerators were used for chemical sensing, where you can send some chemical into the environment while it is tapping. When these gases go and absorb on the surface one of the triboelectric layers, their electronic structure will change. Suppose if you are operating at room temperature and normal ambient temperature and ambient air and all, it has some output voltage. Moment you send some external gas, maybe ammonia or carbon monoxide, the gas molecule will go and stay on the surface of these triboelectric layers and change its work function, maybe electronic structure or electronic properties. As a result, you are going to see different output voltage. As you can see here, this particular chemical is changing its concentration right from 0 to 80 micromoles. You can see the output initially is coming around 275, then it start decreasing with respect to the concentration is increasing. So this can be used as a chemical sensing. So this is also same thing. As you can see, with respect to different ppms of different ammonia gas, this TNG output is getting changed. You can also see the sensitivity. A tribo is not sensitive to all the gases. It is, in this case, this particular TNG is sensitive to only ammonia gas. Other gases is giving a very limited response. So you can clearly say that whenever ammonia is there, your TNG can be used as an efficient sensing element. And this is the work which was done by other researchers. Whatever you have seen is done in our laboratory at Department of Physics, NIT Warangal. Here we have done this all works from Jadal Bank from Georgia Tech, where he has made a triboelectric nanogenerator with a flag shape. Whenever this flags flips left and right with respect to the wind energy, these friction layers get contact each other, going to produce electrical energy. Or this rotation also, these are the two friction layers. Whenever air will rotate this upper arm, this lower arm will be rotating, and these friction layers get attached to each other and rotating each other. As a result, you are going to produce. Or sometimes you can put your nanogenerator to the leaves, maybe for a plant and all. So whenever these leaves flicker, whenever the air passage is there, you are going to produce output. Well, I will show the video here. You can see now there is a nanogenerator attached to these leaves. Now whenever the air is passing by, you are going to have output out of it. Now you can see some small LEDs are glowing outside. So you can connect LEDs to TNG device, and TNG device is here. Whenever there is a contact electrification, your LEDs are glowing. So we can use for wind energy harvesting. You can see more clearly here. This is the friction layer here, and you can see LEDs are glowing whenever the airflow is taking place. You can also use for tidal energy. This is more potential, where you are having a small friction layer. The circular one is the one friction layer, and the inner surface is another friction layer. If you put this center structure in a water medium, water waves will go up and down. This inner spherical ball will move up and down based on the wave energy, and there will be contact electrification that we are going to harvest it for the energy generation, as you can see in this video. Now this is a TNG implanted inside. Now you can see it is able to power these LEDs. So if you have such 3-4 things, suppose if you have something like this. I'm sorry. It's not playing or what? Yeah. You can see now a group of TNG devices, not one. the energy which comes from here, you can see powering so many LEDs, which is free of source. You don't need to have anything. Just put some devices in the water, wherever there are water waves, it will harvest the energy and produce it. And we can also use for rainwater. If rain droplet falls on the triboelectric surface also, you're going to get the electrical output out of it. This is a liquid based TNG. You can see these are the friction layers. Now water is spraying here through the spray nozzle. Whenever the water falls on these surfaces and drop down, there will be contact electrification which continuously light up. Since the water droplets are coming a short period of time and going away, you're going to have continuous lighting here. We can also use for force sensor, touch sensor, as I said just now. So this for health monitoring application. So as you can see, he made a TNG device in this small wristband, which is a small TNG device here. Whenever your pulse, there is a pulse, right? The small pulse will be there. So when the pulse go up and down, the small pressure is enough to produce a current signal which can be monitored for pulse sensing, whether person has pulse or not. This sleep monitoring, which we have already explained. And this is the last application, implantable medical. This is the place where we are interested actually. What we have seen is all the auxiliary application what we have with TNG. So what we have done, what they have done in this case is they have attached TNG device to the diaphragm of the heart. When the diaphragm beats, like when heart beats, the diaphragm go up and down. So that mechanical energy will be converted as a signal. As you can see here, this is the TNG output and this is the ECG output. That what we typically do in a hospital. Both are look similar. Like if you have a TNG implanted to your device, it will give a signal to see what is heartbeat. At the same time, it will give the energy that can be stored in a energy management circuit and can be power the pacemaker. That's the idea. So initial trials were done on this. Initial trials were done on the pork and they could able to generate certain signals and able to monitor also. But still this is under trial stage. It takes years to make actual device to make a completely implantable and self-powered medical devices. So whatever we discuss only limited. We have huge number of applications, right from self-powered system to blue energy to micro machining, and you have hybrid cell, you have a solar cells with triboelectric nano generator, super capacitor with nano generator. There are many other hybrid energy harvesting systems. So we can explore still more. So till this part, we have seen only the positive side of the nano generator. Now we are going to see the negative side of the nano generators. These are the problems and future perspectives, which is limiting us not to explore much. If you look at here, the first one is the AC output of the TNG. As I already told in the first slide, you are going to get the oscillating output. But most of your electronic devices does not run on AC. They will run on the 5 volt DC power supply. So we need to have some energy management circuit, or you need to have a certain kind of a design for TNG which would produce a stable DC output. If you get that, it's a magic. Then you can run almost every device with the TNG. You don't need any battery at all. So this is a potential problem which is stopping us to go ahead further. If you can make this challenge fast, rest will be easy. Low current output of the TNG, this need to be improved. This is not a problem. This is our control because the current will be decided by how many charges are getting transferred. You can kindly modify it, but first one is a typical problem, and the last one is the growth on conducting substrates. So whatever we have seen that I said, there is one electrode on which you are going to put the friction layers. How do you put it? You cannot just attach with a simple tape. You cannot do that. Okay. So if you are able to grow on the substrate, that will have a more mechanical adhesion, because you are going to tap this device several number of times. If it is not grown directly on the substrate, it will just get out of that substrate. It will go off from the substrate. You are going to end up with no output. So if you can make the system or make the deposition or growth on the conducting substrate directly, it will be easy for make the electrical connection as well as the mechanical stability of the film also very good. And we need to go for the large area. You cannot run 5x5 device for practical application. Suppose if you want to make a energy harvesting tile, you need at least 20 centimeter by 20 centimeter, 30 centimeter device. So you need to go for the large scale thing. And this is the problem, long-term stability. Since you are applying a mechanical force on the device, how long your frictional layers are stable. Okay. Suppose you have zinc oxide coating. Your zinc oxide coating may not withstand after maybe 1 lakh cycles or 2 lakh cycles, then your device will not work. You need to look for a friction layer which can withstand large number of test cycles, like say 10 lakh cycles or maybe 20 lakh cycles. If that is the case, then your device long-term stability will be good. And this power management circuit should be done by electrical people to make more efficient way to take all the energy generated by the TNG. So these are the challenges. People who want to work on it, you can work on the first problem, AC output to DC output, and you can also do the strategies to improve the current output, or to find out different techniques to make films on the conducting substrate. And this is the work what I presented is not my alone work, it is group of people who has done or contributed. So these three from physics department, and this from EC department, this from chemistry department, we together as a group, and this is my research team. People who has the work which I presented is from these research scholars work. Okay. And this is today's lab session. You will be showing electrospinning process for preparation of nanofibers and metal argon framework by electrodeposition, and TNG powering LED lamps and touch sensor will be demonstrated in the afternoon lab session. And I thank you very much, and I thank you both the organizers, Venkatesh as well as Vamshi Krishna sir, for providing this platform. If you have any clarification, please feel free to ask. We have, I think, another 15 to 20 minutes time. You are free to ask any kind of question. If there are no questions, I can close down. Yeah, feel free to ask. I am fine with it. No questions? Then I should ask questions then. No questions, right? Sure? That's what, until we get DC output from the TNG, or you make some energy management circuit which takes TNG output, make a stable DC output, okay, then the future is TNG. It is everywhere, it will come. Wherever you want to run any portable sensor, portable device, which suppose you want to monitor a weather condition, maybe you want to measure the temperature outside, you made a temperature sensor which is battery powered. Remove that, keep some triboelectric device which has some mechanical energy source, maybe wind energy or something, it will run automatically. It takes time because initial hard disk, like if you look at in that context, when the solar cells were fabricated way back, maybe 30 years back, the efficiency was only 4%. Okay, it was only 4%, nobody thought that solar cell will come as a commercial product. Now we are getting around 28% efficiency. So it takes time, maybe it may take years also. But there is a scope, at least if not the powering the electron device, worst case you can use as a best sensor which doesn't require any power. Suppose you take the touch sensor, doesn't require any power. You need only one triboelectric surface which is more active to the human touch. Okay. Anything else? Yes. Yes, sir. Those videos are recorded in my laboratory. No commercial product is developed out of it. Few of them we patented it. A few designs were patented it, and few are. See, if you want to commercialize it, you have to compete with the existing products. Okay. See, I cannot sell the touch sensor product because there are already commercial available touch sensors. And there are issues, as I said, right? If I use this device for longer period, let's say 1 year, 2 years, if your film is prone to moisture, okay, if is the moisture sensitive, your film may not produce the same response as day 1 and 365 days later. Okay, there are such issues. You should make a device which will stand for a longer period, larger number of test cycles. Suppose if it withstand, let's say 10 lakh cycles without any degradation in the output signal and without any degradation in the material property, then you can commercialize it. The problem here is, the moment you want to commercialize, the first thing they'll ask is what is the lifetime of your device. So that is where most of the problems will come. Not only this device, if you make any device in any either battery or supercapacitor, whatever you make it, at the end of the first question start from, what is your device lifetime? How long your device will work? You may be saying that my supercapacitor is showing 970,000 and all, but the next question is how many cycles it will stay that capacity? Okay. No, at this moment I do not have any plans because we stuck with several problems. So until we answer them, we cannot go for commercialize. We can only patent it for the time being. This is our idea, that nobody can copy it. That's the only thing we can do it now. Anything else? That's all? So I'm closing down, everyone. Okay, then thank you all for your kind attention.
Thank you, sir. Thank you for the wonderful session. Now we will be going for lunch, and after that the next session will start.
Siemens Center is not there? I heard visit to Siemens Center is there.
which consists of photocatalysis and hydrogen production. So far now, we have seen the introduction, types of nanomaterials, then synthesis process, and application related to the green energy. This talk is about nanomaterial which are used for the optoelectronic properties. So optoelectronic property that can be useful for various applications. First, I will talk about the basic of optoelectronic device, and then later on maybe I will show you how the device can be made. In the morning, we have seen the photocatalysis. So please look at the slide and read the 3 sentences. Okay? Look at the slide and read the sentences. And after reading the sentences, please see how many sentences are correct or how many sentences is correct. Whether 1 sentence correct, 2 sentence correct, or 3 sentence correct, or all of them are correct. I will give you 2 minutes to think about. Okay? So the first sentence is about photocatalysis involve chemical reaction triggered by the absorption of ultraviolet light only. Second, catalysts change in themselves during the overall chemical reaction in photocatalysis. And third is photocatalysis requires special energy sources for efficient operation. So there are 1, 2, 3 sentences. How many are correct or how many is correct sentence?
Sentence number 3. Sentence number 3 is correct.
1 is correct and 3 is correct. So 1 is the photocatalysis involve the reaction triggered by the absorption of UV light only. Okay. And second is catalyst that change themselves during the overall chemical process. Means catalysts participate in the chemical reaction. Change is structure, not change, participate in the reaction. Change themselves means electron, hole, the combination of electron and hole take part in the reaction. Third, they require certain kind of energy source, special energy source is required. How many says 1? 1, 2, 3, 4, 5, 6. Okay. How many says 2? And okay, 2 is no. How many says 3? 1, 2, 3. Please listen carefully. Okay? Please read carefully. Just for another 30 seconds, then. The question is very tricky. All answer is wrong. We are talking about the sun, okay, light energy. Can you see the energy coming from the light? We are talking about the visible light, okay, visible light. Not ultra visible, because we want to use the visible light. We want to use the visible extension of absorption range in visible area. That is our target. Okay? That should be the target for photocatalysis. And catalyst itself, I told you, do not change. But when reaction is going on, he is active. He is active. That electron is moving, coming, going, and that charge recombination process. Okay? Electron goes up from valence band to conduction band, then again comes down, again go, hole is created, hole react. That process I have explained you. So, catalysts participate actively during the photocatalysis. We don't need a special kind of source. We need a light source. Because when you say special, means it is only one or few. You can use the light source in laboratory, or you can use the source like sunlight. That source is okay. You can use xenon lamp having certain wavelength. You can use LED light having certain wavelength. Those are the sources. These are not really special source. It's easily available sources. You don't need to like prepare the special source. But anyway, that was the things I want you to tell which sentence is correct. So number 2 sentence was the correct, and number 1 and 3 is not correct. Catalyst does not change in itself, okay? Its structure is not changing. If catalyst change, then we cannot use again and again, okay? We want to use the catalyst for several terms. If we use the catalyst only one, then we have to use another catalyst. If catalyst change, then there is no meaning. Like you on something and it finished quickly, then you have to reuse it. If you don't reuse, then there is no meaning. Like you on the light and use for 1 hour. If it is gone, then you have to change the light. So that kind of device is not good. Similarly, photocatalysis should be reusable. It should not use one time. That's why the performance of photocatalyst can be determined on his return. How many times we can use? Several times we use. If we use several times or several tons of experiment carried out, and it is found that the photocatalyst gives good performance. Like first cycle, it was 99 or 100%. But by the 10th cycle, like same experiment, you repeatedly doing one cycle, another cycle, third cycle, fourth cycle. At the end of 10 cycle, if the performance goes 10%, 8%, then that is big change. 2-3%, it is acceptable, but 10, 8, 15, 20 is not acceptable. That is not good. Stability of photocatalyst is one of the factors that is more important. If we don't consider the stability, then it is difficult to make the device. Sometimes we might find the material with low cost good to the photo response, but how about stability? So stability is very important. Even you go supercapacitor, any device, stability is important. Then and then it becomes a device. So anyway, catalyst does not change in itself, being or consume overall. Structure do not change itself during the chemical reaction. There are various materials that show photocatalytic capability, and titanium oxide is said to be most effective if we talk about the single. However, ternary is the better. When photocatalyst is exposed to the light in the presence of water vapor, it generates two highly reactive substances. This is the summary of Morning links, that it creates that radical, OH radical and anion. Two kind of radical can be created, and OH is an important part of chemical reaction. So OH can participate to destroy the organic pollutant, and once organic pollutant is destroyed, the contaminated water become clean water or water that can be used for next cycle. So this photocatalyst does not require special energy source. Okay, utilize only clean energy source in our everyday life. So we don't have to prepare a special kind of source. It is already available, and that is solar light from sun. Now talking about lecture number 5, optoelectronics, photocatalysis. So photon, opto, light. So anything which is related to light, we say light. Opto means short form of optical, opto, or photon or photonics. All these terms are almost similar. When we talk about light, we talk about photon. Photon are small particle. So photonics or optoelectronics, they are almost similar. What is the important part in optoelectronics or photonics? Signal travel at the speed of light. The light particle, the speed of light is very fast. So photon travel very fast. Like a light. Photon are the particle, have no weight and no resistance. Almost no weight. They are light particle. So this light particle can be used for optoelectronics. We need to see the signal that are coming, or the signal that can be changed after some kind of maybe treatment or some kind of process you can apply, and it shows change in the signal. Then those kind of application can be a photonic application. So mostly focus light, like this is focus light, anywhere you can focus light, is created by the laser. So laser is also a kind of monochromatic light source. Pulse of photon can be short as 1 million of 1 billion. So pulse created by the laser is very small. You can imagine 1 million of 1 billion of a second. Very, very small. Octo. So nanosecond pulse, femtosecond pulse, octosecond pulse. Very, very small. So those kind of light particle that can show some kind of change, or we use solar light that can show the change. Those light sources or light signal or laser beam are part of optoelectronics. So as light acts virtually contact free, light can move freely. You divert the light but cannot change the light. It can be used as a tool under extreme condition. Now light is an important part of optoelectronics. Whatever application related to the optoelectronics is about photonics, light. So in optoelectronics there are many phenomena, technique, method, device, systems that based on the light and matter interaction. So light encounter with the matter, and that is the part of optoelectronic devices. So this science and technology area is mostly related with the design and realization of electronic driven devices in which information is carried by photons. If you want to change the light signal, you can change it, but in optoelectronics, light is one of the parts that convert into another by sensor or something, but light comes first. Maybe light is detected or light carries something. That is the application of optoelectronics. In optoelectronics, there are several applications. It starts from optical fiber like telecommunication, quantum information, or optical computation, optical interconnection by datacom. These are related to the optical communication. And other application related image, holography, okay, barcode reading. Those are optoelectronic property. So far now, some of the nanomaterial is used in this application, but in future, many nanomaterials will be very useful in these optoelectronic devices. At this moment, some of the devices are big because of the size, but in future, these devices will definitely reduce the overall size. Information storage. So when we talk about the storage, like any storage, before you buy flash memory disk or USB, size was very big, but now size is very small. One, because size is stored by some kind of magnetic material, okay, and that material can store more data than previous one. So 20 years before, 10 years before, whatever USB you have, that was storing 1 gigabyte, but now you can have 100 gigabyte USB of the same size. So you can imagine within last 10 years how we have made a progress in the field of information storage. So that also a part of optoelectronic. Why? It stores the information, but information is detected by light. Okay, information is detected by light. Okay, that's why it is a part of optoelectronic also. And there are various sensors that can be a part of a optoelectronic, instrumentation, metrology, and biomedicine. Now you will say biomedicine. Tomorrow I will show you some of the example of healthcare. So in biological science, many applications can be found based on the laser, various kind of light source that can be used for the biomedical treatment. Today I will mostly talk about the optical devices such as light emitting diode, lasers, solar cell and photodetector. These, while reading this name, you already got the idea that we are talking about light, because either solar is already involved some kind of light emitting diode, light is there, photon. So light, photon is there, so these are optoelectronics. So when we talk about light, so light is photon, and how this light react. When I told you that if you incident the light, the charged particle excited, electron goes from valence band to conduction band. But when electron goes from valence band to conduction band, what happened? How much time this electron stay in this level, and when it bounce back, whether he emit the light or whether he does not emit the light. If it do not emit the light, we call absorption. So you put the light, and if the light is absorbed and light is not passing on, not reflecting, not diffracting, nothing is happened, everything is absorbed, then you cannot see this light, there is no light. All light is absorbed. So that is absorption. But if light is passing, and when it passes, it emits something. So that is spontaneous emission. So this light pass here and go like this. This light pass here and go like this. That is continuous spontaneous emission. And another is stimulated emission. So you pass the light, you can see several waves of light is passing. That is stimulated emission. So this based on the formula that photon, this light has. So light is nothing but include the photon, which is the basic element of light, which consists of frequency and having certain energy with momentum. So this energy allows this light to go, whether it can absorb, whether it can emit or emit in certain waves. So there are three possibilities when we play with the light. So light is important part in optoelectronics. Light absorption, generation in semiconductor are related to the generation and recombination of electron and hole. So everything is related with the movement of electron. Even we talk about simple photocatalysis or even in opto. It is everything about electron and hole. when they go up, whether they are coming. If they are coming, whether they are releasing the energy or not. If they release the energy, which type of energy they release. So that is related to the light and based on the generation and recombination of hole and electron. So optoelectronic devices that are made from the nanomaterial are photodetectors, light emitting diode and laser. So laser has stimulated emission. Photodetector, photon absorption generate hole electron pair. Photodetector, photon light, detect detectors. So something which detect light. In simple language you can say light detection or photon detection. So sensor which detect light is photodetector. In case of light emitting diode, whole electron pair recombination spontaneously generate a photon. And in case of laser is many, I think you already know what laser means. Laser means light amplification by stimulated emission of radiation. The short form, the abbreviation of light amplification by stimulated emission of radiation is laser. So it is an incoming photon stimulate a whole electron pair recombination which again generate photon. So this is because light is photon. So if light is passing, photon is passing. If light go from here to there, the photon is passing. If light cannot go there, everything is absorbed. You might know that the Nobel Prize in the field of LED was given to 3 Japanese scientists in 2014 because they have created blue LED. Now, you will say, why Nobel is given to them? You might read the story or you just see the news. 10 years before, maybe you might be a high school or junior high school student. They made indium gallium nitride and gallium nitride heterojunction on sapphire substrate. Initially, to make the blue LED. And when they make this combination, all of them, they are from different university by the way. So all of them try a certain kind of combination. This was their combination to prepare the blue LED. But the invention of blue LED is very important. Why the invention of blue LED was very important? Because the basic color, green, red and blue. If you have 3 basic color, then you can make any color combination. Any color combination plus importantly white color you can make. You know this white color has 7 different color. It is made up of 7 different color. But the basic color is RGB, red, green and blue. In 1971 and in 1990, red and green LED was already discovered. But blue was not discovered. When blue LED was discovered in 1991, then it was possible to make the white light. For example, if you pass the exam, okay, you pass the exam with 80%. So 80% is not bad at all. But if you want to take the admission somewhere and it requires 90%, so 80% mark is good, but 90% allow you to go for higher study or to get some institute. Unless you have 90%, you cannot go forward in a particular institute. You have option, you can go for other, that is no problem. But your target was to go some institute. So what you need to do, you must achieve that target. So similarly, unless you have blue LED, white LED was not possible. Once they make the blue LED, then now we can easily see LED is everywhere. But what was the difference? What this Nakamura did? This Nakamura basically graduated from Tokushima University Optical Science Department, where I am working now. He was the ex-student of our department. His supervisor is still come to our department. So he was the student of Tokushima University, and after his completing his doctoral study, he joined one of the company in Tokushima called as Nichiya, and there he made this blue LED. After joining Nichiya, once he get this blue LED, he moved to America and joined Santa Barbara University in California, and then he started to work there in 2000s. But what he did in the field of blue LED, earlier this was the combination. This story, why I am telling you the story, if you are a PhD student, you need to think differently. Okay? If you think different way, there are many approaches. Many people follow those approaches. But in PhD, you need to take a risk. You need to think differently. That different thinking is called as critical thinking or deep thinking. So you think totally different. That everybody is using so and so type of things, you will not use it. Everybody is using metal, you are thinking for use polymer. Okay, that is your choice, your thinking. You feel that this will be good. Similarly, what he basically did, instead of using one type of layer, he used a heterogenation of indium gallium nitride and aluminum gallium nitride. That makes a lot of difference. Earlier there was only one indium gallium nitride or gallium nitride, but he added that indium gallium nitride, aluminum gallium nitride, and make that junction, which improve the quantum efficiency. Quantum efficiency means when you think about the light, again electron tunnel, okay, electron move and light is generated. When electron move, it emits the light and we can see the light. So that efficiency 2.7% increase. So the brightness become more. Brightness become more. How much more, that we are going to see soon. So that he made in 1994. That he made in 1994. And that was the beginning of LED era. After that, various combination of LED made, and it was easy to make the white LED. So I was telling you, if you have 1, 2 and 3 color, you can make any combination of color, any combination. But if this blue is missing, you can't make various combination. You might make like this one, you can make, but this you cannot make. Only this and this was possible. 3 was possible, but other was not possible. So due to this blue, several combination, several, no, all kind of color combination is possible. Our television has this kind of RGB plate and we can see any type of color. So same kind of revolution happen in the field of this LED. That's why this LED is now important, and after 20 years, 1994, 2014, 20 years, he got the Nobel Prize, or these 3 scientists from Japan got the Nobel Prize. Now this blue, green and red, how we can generate, make, that was the challenges. So each scientist choose certain kind of material and they create this emission. Once they create this emission, then ultimate goal was done, and there is no more in the field of LED now except to increase the brightness. That's it. But beyond LED there are many things. We have one center in our university that we call Post-Photonics Center. Post-Photonics LED Center. So post-LED means after the LED, what we can do in photonics. There are many things we can do in photonics. So photonics is about the light. And why we are using LED? What is the good thing about the LED? When we started creating the light, first we create like this. We were using kerosene or we were using the oil and some kind of cotton strip, and we were creating such kind of lighting thousands years ago. And after that, this kind of maybe source, incandescent lamp, then fluorescence, then highly intensity discharge kind of lamp, and after that light emitting diode. So if you look at the progress, so this is almost 200-year progress. So within 200, how much we move in the search of light. So this LED, when you compare the LED, so LED already show you how much efficient they have, okay, their efficiency, how much brightness you can get. They can produce high brightness, because if you look at this, okay, this is 100, 150, 470, 800, 100, 1500 and 2000. This is lumen, means intensity. So earlier such type of light, like old type of light or halogen or this incandescent, when you want to generate this much brightness, how much wattage, power you need? Here you need old sources. You need 10 watt to create this much brightness. Okay? Or if you want to create 2000 lumen brightness of light, you require almost 10%, that is 200 watt. But look at LED, 23, 10 times less, 10 times less. So what does it show? Light emitting diode save the power. That is saving power. In the morning session, I told you that we are looking for the green sources. But if we could not find the green sources, what we can do, we can reduce the use of those power. So here LED can reduce the use of power. That's why now everywhere LED is used. 10 times is lots of energy we can save. So this was their story about LED, and this way they can get the Nobel Prize after making blue LED. Why this blue is shown bigger? This is from Nobel website. But if you look at this picture, if your observation is clear, somebody noticed red and green shows in small size compared to blue one. So that shows blue is very important innovation. It does not mean green and red is not important. They are important, but when blue is invented, it was revolution. So that's why this blue is little bigger, and also blue shows more higher intensity. So such type of observation as a PhD student or researcher you should have. Always ask question, why this is big, why light is going there, why this line is there. Some kind of question should increase your curiosity. You should be ready to ask the question. Whether question is correct or not, that is different matter, but always ask question. Now, application of optoelectronics, I told you I will talk about LED, I will talk about solar cell, and I will talk about photodiode, photodetector. So, solar cell is one of the things that we need to have certain kind of progress in the search of power. So, solar cell is work on photovoltaic effect. What is photovoltaic effect? What is photovoltaic effect? You have seen solar cell among you. You just know that solar energy comes to the solar panel and it creates electricity. Done, finish. But how? That working principle you must know. The generation of voltage across PN junction. This is P, this is N type, this is P type, okay? N type, P type semiconductor. So the voltage across this P and N junction is in a semiconductor is created due to the absorption of light radiation is called as photovoltaic effect. So this way it is very simple. Light coming on this, okay? This is the light energy. This is N-type semiconductor, this is P-type semiconductor. Light is coming, there is a change in the voltage across the junction, and this change in voltage is nothing but photovoltaic. Photo, again light, voltage. So that's why photovoltaic effect. And device based on this effect is called photovoltaic device. Then once this change voltage is created, it can convert into the electric power. Because power means change in voltage, potential. The principle of this photovoltaic solar cell is deal with the light that has certain energy. When this energy is greater than the band gap energy of absorbing material which is absorbed, this energy is absorbed by the electron in the crystal lattice. So light is falling on the solar cell. How this process occurs? I told you voltage is created across P and N junction. And once this energy Light has certain energy. It passes on that PN junction and create the voltage. This energy is absorbed by whatever the solar material is used, for example silicon, that silicon crystals absorb the energy. The energy excites electron and it is now free, and hole is left in the electron. Same principle I told you in the morning about photocatalysis. When electron move from valence band to conduction band, the space is empty, hole is created, electron move this. This separation of electron hole create voltage and current. Voltage and current. And this process happen quickly. So this way current is generated with the help of this light only. What are the possible candidate material for solar cell? These days researchers are working on perovskite material for solar cell. Perovskite basically cubic material. So perovskite means such kind of combination, okay? CSPB Br3. So this material basically cubic form, but due to temperature it also occur in different forms such as tetragonal, octahedral, orthorhombic structure. Basically they are cubic form, but they can found in various form like tetragonal, which has 4 atoms, octa, which has 4 atoms and form octagon shape, and otherwise orthorhombic. The electric property governed by Bx. So Bx means, you can see here, this X stand for iodine, bromine and chlorine. But cation does not participate in electronic properties. This part cannot participate in electronic properties. So far now, the problem with the solar cell is the efficiency. This figure, I think you cannot see it clearly, but I think if you see this part, there are various research papers started from 1975. Okay, 75 is here, and this is 2025. Latest figure until last year paper. So far now, 48% efficiency is claimed. But until here, we are not moving much. We are not moving faster. We stuck somewhere in 20 or maybe 2015. We are not moving fast. It's getting like saturation or not moving like this, okay? So this difference is less as compared to, you can see this 10 years. We are not moving, efficiency is not increasing, but people are trying various combinations. So they are focusing on perovskite material because of its high efficiency. So solar must give high efficiency, then it can be used. But perovskite material, why perovskite material? Because they have good absorption. They have good absorption means if solar energy is absorbed, then that voltage will be created fast. Sometimes we need absorption. All light energy should be absorbed. That is the principle of solar cell. If all light energy is absorbed, that can be used for creating electricity. So this is the good material. It can absorb maximum energy as compared to silicon, only silicon, or some kind of composite like CDT, or some kind of CGS type of material or CISC type of material. So perovskite, they have 4 kind of ternary, you can say, compound, 1, 2, Pb and indium. So it has good absorption, and this perovskite material can have good band gap tuning. Various kind of perovskite material can be used, and you can see their band gap. So they have good band gap. Why? Because if the band gap is less, electron can move fastly. Electron can move fastly. The process will be more faster, the efficiency might increase. So in the search of good material for solar cell, perovskite, and among perovskite there are several combinations. This combination is having certain band gap which is tuned between 1.5 electron volt to 1.17 electron volt. So this kind of combination can be varied by the ratio of lead to tin, Pb and Sn. So that Pb and Sn ratio can be varied, and we can tune, we can change the band gap. If you change the band gap, the performance will also affect. This is the working principle of perovskite solar cell. There are glass substrate, FTO, zinc oxide, and what is your material you can add here, and then maybe after having this choice of perovskite material, the solar cell is ready for the application. In last slide I have shown you that there are various combinations that we can use for solar cell. Okay, solar cell. These are various combinations of perovskite material. But perovskite material, why we want to use this perovskite material? Why this material are good? They are eco-friendly, all inorganic material. They are inorganic material. If you see the combination of this, they are all inorganic material. Organic material are not good for this application. So inorganic material are made up of the perovskite solar cell, and this material can be light in weight also. They are stable and shows good efficiency, better than 30%. These are the advantages of perovskite material as compared to other material that are used for the solar cell like CDT, CIGS or silicon. All characteristic based on whether the material cost or preparation cost, raw material cost or preparation cost, fabrication cost or energy payback period, means if you buy the solar cell for certain amount, whether you will get more energy than the solar cell price, and efficiency, those factors, perovskite is more advantageous than other combination. So that's why these days perovskite. In 1990s and 2000, silicon was the widely used material for solar cell. But now research is going on here. Then what about solar cell outside? Which material? Still now we are using silicon, okay? Because this is still under laboratory. Why? That I will show you why this perovskite solar cell is not available in the market. Increase in air and temperature stability is the challenge. So when perovskite solar cell has a temperature above 80 degree, its stability is questionable. It cannot show the good stability at higher temperature like 80 degree, 100 degree. Solar cell, when light energy is coming, temperature more than 100, outside, even though there is a 40 or 45 degree, but if you check the temperature at solar cell, it is more than 100. Water can evaporate. You keep the water on the roof, the water will evaporate. When water evaporates, if the temperature is more than 100. So solar cell has temperature more than 100. So this perovskite do not show the stability at higher temperature. So that need to be answered for future solar cell application. So other problem is PB or lead. PB or lead. These material are considered as absorbing material. They can absorb the light, but finding PB and lead, these are some kind of hazardous material. While making solar cell, that might be questioned. So based on PB and lead free material, when we think about the device, we should avoid PB, because PB and lead is not good for the environment. So that question will always occur while making the device. So this is the one of the challenge. Like earlier maybe talk, I told you non-titanium based material. Titanium is not bad material, but it has some disadvantage and that cannot overcome. So that's why we are looking for non-titanium based photocatalyst. Similarly, lead free material is the future challenge that need to be worked on. And again, when we make the commercial solar cell, the toxicity of PB, yes. Okay. And toxicity of PB is the question. Since it cannot show good performance at temperature and it is like hazardous material, another combination which is based on lead free will be good candidate for the future. Okay. I will skip this slide. Who invented the photo detector? The next is the photo detector. Photon, light. Semiconductor device which can be implemented to detect the photons presence or presence of photon is known as photo detector. So it can detect the light, it can detect the photons. We have Siemens Center here. Today afternoon I visited that center. So I don't know whether you can able to see the center. That center has certain kind of light sensors also, and you can see the real application of photosensor there. So basically it transforms optical signal into electrical signal. First photon is detected, and that detection of light is converted into the electric signal, and you can able to show the photodetector performance. Because something which is made up of light, you have to detect. Once you detect the light, that light signal is transformed into electric signal, and then you can able to give certain kind of information, that is photodetector. So photodetector is based on two principles. One is external photoelectric effect, another is internal photoelectric effect. So electron become free from the metal surface by energy absorption obtained by the stream of incident electron. Here, electron become free. When electron move, electron become free from the metal surface by energy absorption obtained by the stream of incidence photon. So here, this say external photoelectric, and internal free charge carrier are generated by absorption of photon in the semiconductor junction detector. Within, so it is internal; outside, so it is external. So the absorption coefficient and photodiode material, how this photon, when the light is coming, to detect that process of light detection, which type of material has been used. Whether light pass, it shows direct band gap emission or indirect band gap emission. So photon absorption can be a direct or indirect band gap semiconductor. It depends on the material, what type of material you use for this kind of photodiode material. There are various type of material that can be used for photo detector. Like photodiode, PIN photodiode or avalanche photodiode. Different type of photodiode are available in the market. So you can see some of the photodiode here. Photodiode means light and diode. Photodiode. So photo means again light, diode means device that pertaining of two electrons. So P-N junction, that is diode. If you see what is diode means, but normal diode you have only P-N junction, but you are adding photo light. So photodiode is a light sensitive electronic device capable of converting light into voltage or current signal. So you put light on the diode and see the performance, what kind of change it shows in electric signal. So that is photodiode this way. In normal diode you have anode and cathode, but after having the light, it can sense this light, absorb this light, and this light signal is converted into voltage and current. So there are various materials so far tested for this application from 2016 to 2021. Most of the photo detector, photo diode material these days are made up of two-dimensional material. Especially MOO3 is a good material for photo detection. MOS2 with graphene, for example, or some oxide material and MOS2. So those material are good for the photo detection. So with this, I will stop today's talk now. If you have any question on the optoelectronic application, please ask question. This was the last slide for today's talk. Thank you very much. Please ask question if you have any question. I know every day you are tired with the lectures. Any question? Shall I close? Okay, then I will close here. If you have any question, you can ask me in the break. Okay? Thank you very much.